Hi kids, am I audible? Hello? Hi students, am I audible and visible to you all? Hi everyone, welcome to Unacademy NEET English. I'm your biology educator Ambika Sharma. So how are you? A very good evening to all of you. Good evening, good evening, good evening. Thank you so much, Jay, for waiting for the videos. And today it is the second part of breathing and exchange of gases. We have already discussed the basics of this particular chapter, like the respiratory organs in lower organisms, about the human respiratory system. We have already discussed. So today mainly we will start with the alveoli part and then mechanism of breathing, pulmonary volume, capacities. That's what we are going to cover today. Okay, so if you guys are having any doubt from the topics that we have covered or anything that you want to ask, you're free to ask. And you know what you have to do. If you're new to our channel, please subscribe our channel and share the session link with other students as well. Ask them to join this session, because here in this particular chapter, in this particular session, we'll be covering the entire NCERT of breathing and exchange of gases chapter. And then bache, I am going to ask many questions from you as well. Fine. So if you have any query, just let me know. And yes, one more thing I want to ask, that which topic you want me to discuss. Like last time you were saying that strategy, then ma'am, we want strategy to crack the NEET examination. Anything else you want me to discuss? Okay, soon you are going to get Plant Kingdom 2. Okay, don't worry about that. Anything else you want me to discuss? So here you guys can see our channel. Just look at it. See, look at the video section here. Whatever is baffling your mind, right? You just put the topic here and you will get the solution. See, your HSP sir has shared the roadmap for the organic chemistry, right? That how can you complete your organic chemistry for the NEET 2024. Here you can see I have posted the video where I have shared the cutoff list of the AIMS colleges, right? Everything related to AIMS you will get it here. And see, Shreyas sir has posted the strategy video, Wazeem sir has posted the strategy video. Look at my videos as well, the complete strategy to crack the NEET examination. If you guys are going to start now, if this is your topic, watch this video. And how to score more, how to cover syllabus fast in less time, everything you will get here, right? So on this channel, we are not just providing you the quality content, we are not just delivering the academic content here, but other than that, whatever is required for your NEET preparation and whatever is required for your career, right? We are posting it here. So stay tuned to this channel, be the part of this channel, and please subscribe our channel. Let's make it 100K family as soon as possible. What say, guys? Yes? And what else you want me to discuss? Ma'am, can 2025 students join Avengers 2.0? Yes, Varsha, you can join, because currently we are going for the human physiology sessions, and moreover, there will be the revision sessions of the chapter that we have covered, and then we'll start class 12 syllabus. Anything else? Syllabus completion strategy, just go watch this video. Watch this video. How to complete backlogs? Nandini, I'll make video on that. What else? So if you have started now, still go and watch this video. Watch this video. You'll get the answer of each and every question. And if you want to join our Avengers batch, you know what you have to do, right? Just go click any of the video, right? And then see here, this is the description box. Here you have the link. Click on the link, add your number, your email ID, you will be the part of. Then after paying fees, obviously you will be the part of Avengers 2.0. Now let's start the chapter. Let's start this particular topic, that is breathing and exchange of gases. Okay, so quick revision. Let's start with the quick revision. So the first thing is, what is breathing? You know that it is the first step of, right? First step where there will be the exchange of gases. Yes or no? It is the first step where there will be the exchange of gases. See, when we talk about the energy, you know that energy is very important for us, isn't it? For our activities, for our functioning, energy is very important for us. You all are well aware of it, right? So we talk about the respiration. What is respiration? It is a multi-step process. Let's revise it very quickly, okay, so that you can recall whatever we have completed so far, and then we will move. Fine, then we will move. So first of all, tell me, how's your energy? How's your energy? How's your energy? Just let me know quickly, everyone. Quickly. Are you feeling energetic? If you are feeling energetic, then hit the like button and everyone is going to answer the questions that I'm going to ask. Jayashri is saying, when will you start genetics? I have already started genetics. Right? In the morning at 10 a.m. I used to take the session. Sometimes 10:30. Okay. And tomorrow also you have one session. Right? And from your response, this is what I'm feeling, that you don't want to study genetics. Ah? Is it so? If not, then quickly hit the like button and focus here, guys. Please stay tuned to our channel. Please hit that bell icon so that you will get update of all the chapters that we are starting and we are taking. Okay, so breathing and exchange of gases, this is what we are discussing. So as I said, it is the respiration. What is respiration? When you talk about the respiration, you are talking about the complete oxidation of your respiratory substrate, that is your glucose. You know, we need energy. We need energy for our metabolic activities. We need energy, right, for our for all the activities that we need basically metabolic activity. So when you talk about the respiratory substrate, and you know that that is glucose, so we need to oxidize it in the presence of oxygen. It will be oxidized in the presence of oxygen, and of course that energy will be released, and we will trap that energy in the form of ATPs. Very simple it is. Glucose will be oxidized in the presence of oxygen, energy will be released. We are going to trap that energy in the form of ATP, and this process is going to be a multi-step process. Right? It is a process which is dependent on enzymes, and it is a multi-step process. It is not going to take place in one go. Slowly energy will be released. We will use that energy. We will make the ATP. Okay, the chemical form of energy. Ultimately, that is what we need, ATP. Okay. So when you talk about the respiration, so breakdown is there. So obviously it is a catabolic process. Ultimately, what is going to happen here in respiration? There will be the breakdown. So catabolism is there. Catabolic process it is. But moreover, students, when you will study this chapter, I'll start plant physiology, respiration in plants. You will discuss this process there. So we used to call it amphibolic. What is the meaning of amphibolic? Amphi means dual, right? That here, because it is a multi-step process, so sometimes there will be the breakdown, sometimes there will be the build-up. So ultimately it is going to be the amphibolic process. That's what we have discussed in the last class. Now when you talk about the different type of respiratory organ, like if you talk about the animal kingdom, let's talk about the animal kingdom. So when you people talk about the animal kingdom, so you know one thing very clearly. Okay, you know one thing very clearly when you discuss this animal kingdom, that here we have different type of organisms, right? From porifera to chordata, we study different type of organisms, isn't it? And because we study different type of organisms here, right? So we know that their habitat, okay, their habitat and the level of organization is different, isn't it? Their habitat and level of organization is different, isn't it? And this habitat and level of organization will decide. What will it decide? The type of respiratory organ. Okay, the type of respiratory organ. This is what we have covered, right, bache? Right, bache? So porifera, you know that cellular level of organization is there. Then Cnidaria we have Ctenophora, Platyhelminth, Esculminth, Annelida, Arthropoda, revise it with me, right? Then Annelida, Arthropoda, Mollusca, Echinodermata, Hemichordata, Chordata. We have different phylums, different organisms are there. Their level of organization is different, their habitat is different, and that will decide the respiratory organ. So in this process of respiration, right? In this process of respiration, bache, it is the breathing which is the first step. Okay, it is the breathing which is the first step and which means exchange of gases. What is the meaning of breathing? It means exchange of gases. Okay. So this is what we are going to start today, because already the basic introduction of human respiratory system, we have completed that in the last class. Fine, we have completed that in the last class. So you know that this snip is from your NCERT. So just look at it, bache. So respiration involves the following steps. So the first one is breathing, also known as pulmonary ventilation. Ventilation is there na, CO2 will out, CO2 will pass out, it will be exhaled and oxygen in. CO2 out, oxygen in, right? So pulmonary word is associated with your lungs. So basically it is the ventilation of your lungs. What is it? It is the ventilation of your lungs. Okay, so atmospheric air is drawn in and the carbon dioxide rich alveolar air, it will be released out. So the second step here is going to be the diffusion of gases. Now obviously air will move in, oxygen will move in, so there will be an exchange. Okay, so diffusion is going to take place. This is what we will cover today. Fine. And then we need to transport these gases, and you know that in the human body we have the blood, which is our vascular connective tissue. Next to it is the diffusion of oxygen and CO2 between blood and tissue. Here it is across alveolar membrane. It is also the external respiration. Here it is in between blood and tissue. It is the internal respiration. And finally, we are going to utilize that oxygen. Energy will be released. Catabolic reactions will be there. This is the cellular respiration. Are you getting it? This is the cellular respiration. Clear, bache? So here we have these 5 steps. You should know the sequence as well. And there is nothing to cram here. Obviously, oxygen will enter in the lungs. Alveoli is the primary site. Exchange of gases will be there. Then we have to transport that gas. Tissue is going to take that oxygen. Tissue will give back the CO2. Tissue will use the oxygen. Simple as that. Any doubt here? Yes, any doubt here? Now, bache, the quick revision of this system. Okay, we have already covered it, but still, let's have a quick revision of this system. Let's talk about the human respiratory system, that complete route now we are going to discuss. Fine, bache, right? So you know that we start from external nares, that is your external nostril. Okay, we are going to start from external nares, that is your external nostrils. And do you know, Nandini, it is a question, it's a previous year question. These external nares, they are compared with the spiracles of the cockroach, or you can say that spiracles of the cockroach are compared with these external nostrils. Why? Because it is a from these apertures, air will pass in. Okay, air will enter in the body of the cockroach as well, and even in the human body. So from external nares, you know that next to it is the nasal cavity that we have, है ना? Nasal cavity that we have. Revise it quickly. External nares, this is the nasal cavity. The nasal septum will divide it into, here you guys can see that nasal septum will divide this nasal cavity into nasal chambers. So here you will see here, you will see some sebaceous glands, you will see olfactory epithelium here, isn't it? You will see olfactory epithelium here. Then comes, bache, internal nares. Okay, and from internal nares, the air will be passed to the pharynx. Remember this part? Air will be passed to the pharynx. Remember this part? So pharynx is having node, 3 parts. What that pharynx contain? It contains 3 parts. Right? How many parts are there? 3 parts are there. First is your nasopharynx, then comes your oropharynx, then comes your laryngopharynx. That's what we have. Nasopharynx, oropharynx, laryngopharynx. Nasopharynx, oropharynx, laryngopharynx. That's what we have. Yes, bache. That's what we have. Clear? So, you know that this air will pass to, from this internal nares, it will pass to the nasopharynx, then to oropharynx, then to laryngopharynx. And you know oropharynx is a common passage. It is the common passage for the food as well as for the air. It is a common passage for the food as well as for the air. Is that clear? Yes, everyone. Is that clear? So oro then comes to the then the laryngopharynx is there, and from this laryngopharynx, bache, see, imagine this is the dorsal side, this is the ventral side. It will further leads into the larynx, and the opening of larynx is glottis. Right? Opening of larynx is glottis. And you know that glottis is covered. See, have a look. This glottis, see, this is the larynx. the opening of the larynx, I'm going to draw it in this way. Opening of this larynx is what? It is the glottis. Clear, bache? It is the glottis. And this glottis will be covered with a cartilaginous flap, epiglottis. So epi means above. Something is above glottis. Okay, so it is just like a lid. Okay, you have a bottle, then you are putting a lid. Just imagine you are going to swallow the food. Okay, you are going to swallow the food. So this opening is the glottis of the larynx. You are going to put epiglottis like this when you swallow the food, right? Because food should not enter here. Otherwise, suffocation can be there, choking can be there. Fine. So larynx, next to it is your trachea. Hope you remember this, right? So at the level of 5th thoracic vertebrae, your trachea will bifurcate into 2 primary bronchi. Is that clear? Is that clear? So next to the larynx will be your trachea, the windpipe. So at the level of 5th thoracic vertebrae, this trachea will bifurcate into 2. That is your primary bronchi. So it is for the quick revision. I hope you are getting this part. Yes. So this is the complete pathway that how air is going to enter within the human body. Fine. So trachea, then comes the primary bronchi. Okay. Then secondary. Yes, everyone. Then secondary bronchi. Next to it is tertiary bronchi. Next to it is, yes. So first is primary, then comes the secondary, then comes the tertiary. So next to it is what? Yes. Next to it is what? Quickly tell me. This is the respiratory tree that we used to discuss now. It's very simple, Nandini. So just go for it. So what will you see here? What will you see here next to it? It's tertiary. Very good. Excellent. So here you will see the terminal bronchi, right? Terminal bronchi, and next to terminal bronchi will be initial bronchioles. Okay. So let me draw it here. So let me write it here. So here you will be, okay. So you will be having your lobular bronchiole, or you can say that your initial bronchiole. So trachea will form bronchi, bronchi will form bronchioles. Okay, bronchi will form bronchioles. And let me tell you, students, this trachea, your primary, secondary, tertiary, terminal and initial bronchioles. Basically from trachea to terminal to initial bronchioles, they are covered with C-shaped, incomplete, na? They are C-shaped like this. So they are covered with incomplete cartilaginous rings. Fine. They are covered with what? They are covered with C-shaped cartilaginous rings. So that these pipes, these structures, they should not collapse when we breathe air in, right? Because of that pressure difference, they should not collapse. That's why. Fine. That's why. So this is the complete pathway by which the air will flow, and finally it will enter in our system. So after lobular bronchiole, you know what do we have? We have the terminal bronchiole. Okay, and after this terminal bronchiole, the next to it is your respiratory bronchiole. Then is alveolar duct, and finally the alveoli. Clear, bache? So this part here, can you see this part here? It is actually the exchange zone. It is actually the respiratory zone. This is what you need to understand. So from external nares to this terminal bronchiole, from external nares to this terminal bronchiole, it is the conducting zone. What is the meaning of conducting zone? This is the nasal, this is the pathway, this is the airway, or this is the air passage that is going to conduct the air towards the respiratory zone, towards the exchange zone. So actually these are the alveoli, which are some sac-like structures, and it is actually the primary site for exchange of gases. Is that clear? It is actually the primary site for exchange of gases. So that's what you need to remember. Fine. That's what you need to remember. Fine. So respiratory bronchiole, alveolar duct, alveoli, the exchange zone. Right, the respiratory zone it is, and rest is just the conducting zone. So bache, this conducting zone, it's not like that it will just conduct air, it is also going to humidify it. It will add some water content in that air. It will bring the temperature of this air equal to the body temperature. Fine. It is going to bring the temperature of this air equal to the body temperature. And yes, it will also do the filtration. So any doubt here? Yes, everyone. Any doubt here? So now quickly move to the structure, which we have already covered, but you know that, right? What are the rules? What are the rules? If you are the student of Unacademy NEET English, then you know it very well. If you are my student, you know it very well. That every time, whenever we start the next lecture, we always revise what we have done earlier. Okay? And guys, if you are looking for the classes, genetics classes, so you know now, I have started it in the morning. Right? I was going I'm literally going very slow. Very slow there, because I know when it comes to genetics, you need time. That's why. Fine. So do check that lectures as well. So see, here you have the, here you have what? Here you have the lungs. So lungs are present here in thoracic cavity. We have covered it in last class. Okay. So lungs are covered with the layers. No doubt lungs are present in anatomically. Lungs are present in an anatomically airtight chamber. Where are they present? They are present in anatomically airtight chamber. Why do we say so? What is the need? Why do we say so, Ishwat? Can you tell me? I am saying that lungs are present here in that anatomically airtight chamber. What is the meaning here? See, if you will see, dorsal side is having the vertebral column, and it was your homework. Which vertebrae are covering this? You know, which vertebrae are the part of this airtight chamber? Right? Whether cervical vertebrae are there, or thoracic is there, or lumbar is there. This is what you need to tell me. That's your homework. So dorsally, vertebral column. Ventrally, sternum is present. Ventrally, what do we have? We have sternum, also known as breastbone. And laterally, ribs are present. Right? Laterally, ribs are present. And bache, towards the lower side contains your flat-shaped dome-shaped diaphragm. Okay, it will contain your dome-shaped diaphragm. So it is closed, isn't it? It is closed, isn't it? Isn't it? So it is closed, and it is present here in such a way that it forms an airtight chamber. Okay, it forms what? It forms an airtight chamber, right, bache? So here you have the lungs. See the ribs here. This is your dome-shaped diaphragm, which is a unique feature of mammals. It is separating your thoracic cavity from the abdominal cavity. Okay, it is separating your thoracic cavity from the abdominal cavity. Are you getting it? So we have pair of lungs. What do we have, students? We have pair of lungs. So look at this, right? This is your right or left lung? Tell me. This is your right or left lung? So actually, bache, this one is your right lung. And when you talk about the right lung, it is broader and narrower. Remember this part. Okay. See, and if you want to understand these things in more detail, please check the last part. Fine, please check the last part. So right lung, which is broader and narrower. Why, bache? Because just below this lung, right here you have the diaphragm, and just below it we have the liver. And in the case of liver as well, right hepatic lobe, it's quite big, isn't it? Isn't it? So lungs are broader and the right, not the narrower. It is broader and the shorter. It is shorter and broader, like this. Okay. Okay. So now this is the left lung. So when you talk about the left lung, it is having two lobes. How many lobes are there? Two lobes are there. Here you will see three lobes. Fine. Here two lobes are there. And left lung is going to be, it is going to be longer and narrower. What is it? It is longer and narrower. And in the left lung here, see here, this part is your cardiac notch. Fine. So actually what is happening here, just look at it. What is happening here actually? See, you have the pair of lungs. So there is a space in between the lungs. Can you see that, Misha? There is a space in between the lungs. So this space present in between the lungs, this space here, which is present in between the lungs. Can you see the space which is present in between the lungs? We used to call this space as mediastinum. What is it? It is mediastinum, the space in between two lungs. So here you will see your heart, you will see the thymus, you will see the part of diaphragm, you will even see thoracic duct, which is your lymphatic duct. Okay, so the space here is mediastinum, your heart is present there, and heart is in the center, a bit pushed towards the left side. That's why it is forming this cardiac notch here in the left lung. Is that clear? It is forming this cardiac notch here in the left lung. Is that clear? Yes. Is that clear? And bache, these lungs are, okay, these lungs are covered. See, they are covered with the pleural membrane. Which membrane is covering it? Which membrane is covering it? Pleural membrane. So you have inner pleural membrane. You can also call it as pleuron. And you have outer pleural membrane. You have inner pleural membrane and you have outer pleural membrane. And the space in between two, this space in between two is your pleural cavity. And bache, this pleural cavity is having the pleural fluid. Clear? So outer pleural membrane, parietal pleural membrane, inner pleural membrane, visceral pleural membrane. In between the pleural cavity is there. So pleural cavity is having the pleural fluid, which will obviously provide lubrication so that lungs can move smoothly. Fine? Fine, bache? Right? So this is what I hope. I hope you remember this part. Clear? I hope you remember this part. And about the alveoli, we will discuss it. But once, let's finish the mechanism of breathing and then we will talk about the alveoli. So when you look at this, this part of NCERT, when you look at this part of NCERT, see, always when you read NCERT, whatever is written in the bold letters, you should know the meaning of that words. Although you need to read each and every line of NCERT, I'm not saying that you should only read bold letters, but you have to make sure that at least you understand the meaning of that letters, right? That bold letters. Fine, fine. So here, see, we have discussed everything, and in detail about the alveoli, we will discuss it after the mechanism of breathing. Fine. Okay, bache. So that's what you need to remember. And yes, it is also a previous year question. Yesterday, in our Avengers batch, I was taking one class on question practice. So we were solving this question. They have given few structures and they were asking, out of the following, which one is completely cartilaginous? Okay, which structure is completely made up of cartilages? So the answer is larynx. Larynx is a cartilaginous box, bache. It is just made up of cartilages. Clear? It is just made up of cartilages. Fine? It is just made up of cartilages. Clear, bache? Clear? So this structure clear? Yes, the structure clear. Now this is the part from NCERT that I was talking about. See, lungs are situated in thoracic chamber, which is anatomically an airtight chamber. Thoracic chamber is formed dorsally by vertebral column. See, ventrally by sternum. It is written na. Everything is written na, ventrally by sternum, laterally by ribs, lower side is having dome-shaped diaphragm. So this setup is such that, this is a very important line, students. Please mark it, please highlight this. This anatomical setup of the lungs in thorax, this anatomical setup of the lungs in thorax is such that any change in the volume of thoracic cavity, if there is any change in the volume of thoracic cavity, it will be reflected in the lung cavity. This is something very important, right? See, now after this, we are going to start mechanism of breathing and we are going to use this particular point here, right? Right? So please mark it. Kindly mark it in your book. Okay? Kindly mark it in your book. So what is written here? That this anatomical setup of lungs in the thorax is such that if there will be any slight change in the volume of thoracic cavity, it will reflect in the volume of lungs as well. Fine, it will reflect in the volume of the lung cavity as well. And this arrangement is very important for the breathing, and as we cannot directly alter pulmonary volume. So this is the part that I need to explain now, and with the help of it, you will understand the mechanism of breathing as well. It is very simple. See, lungs are present here in the thoracic chamber. Clear? Lungs are, see, diagrams are bad, but it will clear your topic. Okay, so these are the pair of lungs that we have present in thoracic cavity. So they do not have any such structure. If you talk about the lungs, what are they? Soft, spongy, pinkish structure, isn't it? What is it? It's a soft, spongy, pinkish structure, right? They are soft, spongy, pinkish structure. Yes or no? And even it is elastic. Even it is elastic. Clear? That's what lungs are, isn't it? Pinky, pinky. That's what lungs are. So they do not have any such setup, right? Right? If you talk about lungs, you know that they are having that alveoli, they are having all that, you know, bronchioles and the bronchi, bronchiole network. Then they have the alveoli. You know their structure, isn't it? You know their structure, isn't it? Isn't it? Honestly, I don't want to laugh, but actually it's a fact. CM is right. It is actually looking like a pig nose. And this diagram is actually looking like that. But you please try to imagine them as lungs. Please. Right? I know it is looking like a pig nose. Now even I can relate, but please try to imagine that these are the lungs. These are the pair of lungs. Okay? These are the pair of lungs. So all I'm saying is that they do not have anything that can alter their volume. But this arrangement here, the placement of these lungs here in the thoracic cavity, you know, na, here your pleural membranes are also there. Parietal pleural is fixed here with the thoracic cavity. So this arrangement is like that, right? This arrangement is like that, that if I will increase the volume of thoracic cavity, it will alter the volume of lungs as well. Are you getting it? If there is the increase in the volume, see, if you will focus here on this particular axis, this is what you will see. You will see that volume will increase, right? You will see that volume is increasing. Volume has increased. Fine. So ultimately, if there is change in the thoracic volume, it is changing your pulmonary volume as well, your lung volume as well. Clear? Clear? Sure? Sure. Now let's start the topic from where the question can come, and that's your mechanism of breathing. That's your mechanism of breathing. That's what we are going to start now. So when it comes to the breathing, you have two things. Ultimately, we have to draw the atmospheric air in and we have to breathe out the CO2 present in the alveoli. So here you have two steps, right? One is the inspiration, that is also known as inhalation, and another is the expiration, which is also known as exhalation, isn't it? Inspiration, also known as inhalation, to inhale, and expiration, it means exhalation, to exhale, isn't it? To exhale, isn't it? Isn't it? So we are basically, if you want to understand this topic, you should understand few terms. One is what is the meaning of diffusion? What is the meaning of partial pressure? And what is Boyle's law? That's what you need to understand. What is diffusion? What is partial pressure? What is Boyle's law? This is what you need to understand if you want to know about this. And then comes few muscles. Okay, then few muscles. Fine. So if you know about it, then obviously you are going to nail this topic. Fine. So diffusion, partial pressure, Boyle's law, and then comes your muscles. That's what we need to know about. Okay. So the very first thing, let's start with the diffusion. Okay. Firstly, I will explain these terms to you, and then we will discuss this mechanism of breathing. Fine. Then we will discuss this mechanism of breathing. So up to this part, any doubt? Yes, anyone having any doubt here? Sure. So when it comes to the diffusion, what is the meaning of diffusion? Right? What is the meaning of the simple diffusion? Diffusion is the movement. Okay. Here we are talking about the gases. So let's take the example of gases. So it is the movement of gases. It is the movement of gases from their high concentration to their lower concentration, and ultimately that's what you need to understand, bache. If you want to understand this chapter, this is what you need to understand. If you know about it, then everything will be clear. Okay, if you know about it, then everything will be crystal clear to you. So what am I saying? We are talking about the simple diffusion. What is the simple diffusion? It is the movement of gases from their high concentration, or you can say that from their high pressure to their lower pressure. Right? Here we are talking about gases. So I'm taking the example of gases. You can simply say movement of molecules from their higher concentration to their lower concentration. Okay, from their higher concentration to their lower concentration, or you can say that from their higher pressure to their lower pressure. Okay, from their higher pressure to their lower pressure. Now what's the point here? So here basically what do we have? We have a gradient, right? We have a gradient, like either you will see the concentration gradient or the pressure gradient, whatever you want to call it. Like, what will you see here? Either you will see the gradient here. What will you see here? You're going to see the gradient here, the difference here. Okay, it can be pressure difference, it can be concentration difference. It can be pressure difference, it can be concentration difference. Say for an example, like let's say two people are there, they have the same amount of money. So why are they going to exchange, right? One is having 100 rupees, second one is also having 100 rupees. Why will they exchange? If let's say one is having 100 rupees, another one is having 10 rupees, then that person will say that yes, okay, you have 10 rupees, I'll give it. Right? I'll give my money to you. Like this. Like this. Getting it? So basically here, what is important? The gradient. The gradient, there should be a difference. Then only the movement will be there. Right? Then only the movement will be there. So because it is a simple diffusion, so here the flow is along the concentration gradient, here down the concentration gradient. I'm explaining you the basics of diffusion. Yes or no? I'm explaining you the basics of the diffusion here. What am I saying? I'm saying here that when we talk about the simple diffusion, the things are moving along the concentration gradient. The things are moving down the concentration gradient. Right? From high to low, there is the movement. From high to low, there is the movement. So it means it is passive. It means it is passive, it is not active. So what is the meaning of active movement? Where energy is involved, where ATP is involved, like active transport, where movement is from low to high. Right? Movement is from lower concentration to the higher concentration, but here it is passive along the concentration gradient. Is that clear? Is that clear? So now let's say if I want to breathe in, if I want to draw the atmospheric air in, see, this is your atmosphere, okay, and here this is my lung cavity, my lungs, okay. So if I want to take the air in, if I want to take the air in, see, ultimately it is the diffusion that is going to take place. Fine, you have studied that steps of respiration, you know we were talking about the diffusion. Okay, we were talking about the diffusion. So if I want to draw the atmospheric air in, what should be there? The pressure difference. Here the pressure should be more. In the atmosphere, the pressure of the gas should be more. And in the lung cavity, within the lung cavity, that pressure should be low. Understood? Yes, understood? Understood? So if I want to breathe in, if I want to inhale, if I want to take the atmospheric air in, so my lungs should have low pressure, right? My lungs should have low pressure. Outside pressure should be more, right? Outside pressure should be more. Clear? Clear? So the another point that you need to understand here, see, now when you talk about the air, don't you think that air is the mixture of gases? Yes. We are going to breathe, we are going to take air in, right? We do not have any filters which are going to decide, okay, this is the amount of oxygen, I will take oxygen only. It is not going to happen. You are going to take the mixture of gases. Mixture of gases. So I hope you know Mr. Dalton's. I think if I'm not making the mistake here, Mr. Dalton, hai na? Mr. Dalton explained it. Ki, what is the? So here we are not talking about the pressure, we are talking about the pressure. Partial pressure here. What are we talking? We are talking about the partial pressure here, if you remember. So because air is a mixture of gases, it is having many gases. Like if I talk about the oxygen, oxygen is near about 21%. Nowadays, you know that it is affected because of pollution, but otherwise, this is what we used to study, that the CO2 is near about some 3% or something, its amount should be less. Although because of pollution, it is increasing. Even nitrogen is there in our air. Many gases are there in our air, but what do we need? We need oxygen, because it is the one which will oxidize my food. It is the one which will break down, right? Which is going to break that. Which is going to break that. What? That glucose. Clear, bache? Mr. Manikandan, mind your language or leave this chat section. Otherwise, I have to block you guys. Kandraz and Manikandan, leave the chat box, please. So oxygen is near about 21% if I'm not making the mistake here. Isn't it? Isn't it? Yes or no? So when you are talking about the air is a mixture of gases. So when you are talking about a mixture of gases, each gas is contribute. Each gas is going to contribute there. Each individual gas is having its pressure, and we use the word partial pressure for that. Fine, we use the word partial pressure for that. Are you getting my point? So I am saying that air is a mixture of gases. Each gas is having its own pressure. We used to call it as partial pressure. So Mr. Dalton has explained it if I'm not wrong. Isn't it? He has explained it if I'm not wrong. Help me now. You know, na, even I was about to, even this year, even I will prepare for the NEET. Right? I forgot about it. You have given me some chapters, no? Then ma'am, do these chapters. That's all. Hai na? Chalo. So this is the partial pressure. So here, whenever you will talk about this exchange, we will majorly be focused on partial pressure of oxygen and the partial pressure of CO2. Why? Because it is the oxygen that we need in. It is a CO2 that we want to throw out. It is that metabolic waste. It is that gas that we want to exhale out from our body. Fine. So we are going to talk about the partial pressure. This term clear? This term clear? Okay. So what is partial pressure? What is the simple diffusion? Everything is clear to you? Everything is clear to you? What is the meaning of inspiration? To inhale the air in. To withdraw the atmospheric air in. What is the meaning of exhalation or expiration? To release the air out, to release the CO2 out. And how is it possible? With the help of simple diffusion. For diffusion, what is required? Especially for inspiration, inside the lungs, the pressure should be low, then only atmospheric air will come in. For exhalation, what is important? Inside, the pressure should be more. Outside, the pressure should be low, then only it will go out. So if you want to take the oxygen in, so what should be there? What should be there? Here, the partial pressure of oxygen is low. If you want to exhale the CO2, here the partial pressure of CO2 is more, outside it is less. Basic it is. Clear? Basic it is. Now you need to understand one more law, that is known as your Boyle's law. Okay, so now we will talk about one law, that is your Boyle's law. Fine, that is your Boyle's law. Okay, what is the meaning of this law? Yep, what is the meaning of what this law states? Tell me what this law states, Boyle's law. You know that as per this law, volume and pressure, they are inversely proportional to each other, isn't it? Volume and pressure, they are inversely proportional to each other. Yes or no? Yes or no? It means if volume is increasing, pressure will go down. If pressure is increasing, volume will go down. Volume will go down. Yes or no? If volume is increasing, pressure will go down. If pressure is increasing, volume will go down. That is the meaning here. Yes? Done? Yes? So volume is increasing, pressure low, pressure is increasing, volume low. Clear, bache? They are inversely proportional to each other. Now, why are we discussing it? Simple. If I want to inhale, if I want to take the oxygen in, so of course, in that case, pressure should be low, right? Within my lungs, in my lungs, the pressure should be low, means I need to increase the volume. Is it understood? Is it understood? If I want to take the atmospheric air in, and if I want to take the air in, so obviously the volume should be more and the pressure should be low. This is what we need. Okay, this is what we need. And for the exhalation, you know that the story will be opposite. For the exhale, if I want to exhale, the pressure should be high within the lungs and the volume should be low. Isn't it? Understood? Yes, understood. Now, here we need the role of the muscles. Clear, bache? Now we need the role of the muscles. Now, muscles are required to achieve it. And here, what are you going to discuss? Mainly, you will be talking about the intercostal muscles. Okay. Intercostal muscles and the diaphragm muscles, peripheral muscles especially. Peripheral muscles of diaphragm. So these are the muscles that we need to discuss now. Clear? Intercostal muscles and diaphragm muscles. And when you talk about the intercostal muscles, here you have external intercostal muscles as well. Here you have internal intercostal muscles as well. Are you getting it? Are you getting it? So what are we going to talk about? We are going to talk about the muscles now, because they are going to help in maintaining that volume. So you will be talking about intercostal muscles. So I will use the short form ICM for it. And then comes the diaphragm muscles. And here intercostal muscles are of two types, external, internal, external, internal. Is that clear? External ICM will be there, internal ICM will be there. Okay, external ICM will be there, internal ICM will be there. So this is what we need to know. This is what we have, this is what we need to discuss. And yes, we are also going to talk about the abdominal muscles. Don't worry about that. Okay, we will also be discussing about the abdominal muscles. Okay, so it is clear in your mind that what are we going to discuss next? Fine, it is clear now that what are we going to discuss next? Okay, so let's start with the intercostal muscles. Or what do you want to start? Diaphragm muscles or intercostal muscles? Tell me. What do you want to start first? Diaphragm muscles or the intercostal muscles? Chalo, let's start with the diaphragm muscles. Okay, let's start with the diaphragm muscles. So first of all, look at the structure. That's how things are present. That's how things are present, right? Here you have your lungs. Look at it. How is it covered? See, here. The lower side will have dome-shaped diaphragm. Here you will see this. This is your shoulder. This is your collarbone. Clavicle. Fine. This is your collarbone, clavicle. This part is your shoulder bone, scapula. Okay. Okay. And here you have the sternum. This is sternum. Fine. And these are the ribs. Bicephalic ribs we have. Bicephalic ribs we have. Okay. Okay. So this is an anatomical air chamber. Na? Backside is having your vertebrae. So just look at it. See, these muscles present in between ribs, they are intercostal muscles. They are intercostal muscles. So what are intercostal muscles, students? What are these intercostal muscles? Yes, if this is a, so imagine if these are two ribs. So in between these two ribs, the muscles which are present in between these ribs, they are basically known as your intercostal muscles. Any doubt? They are known as your intercostal muscles. So the word here is external and internal intercostal muscles. Right? What is the word here? It is external and internal intercostal muscle. What is it? It is external and internal intercostal muscle, isn't it? So see this. Look at it. Can you see this part? Yes, can you see this part? So obviously intercostal, which is present in between ribs, which is towards the outer side, external side, that will be external intercostal muscle, which is towards the inner side, internal intercostal muscle. Like let's say, imagine just take the example of these two fingers. Okay, just take the example of these two fingers. Okay, so see, let's say this pen is in between. These are your intercostal muscles. So one which is present towards the outer side, it is external intercostal muscle, and the one which are present towards the inner side, they are internal intercostal muscle. This one is external, this one here is external, this one here is internal, this one here is external, this one here is internal. Got it? Yes, got it? So that is the position of the muscles. See this. Okay, doubt? Any doubt about the position of the muscles? Any doubt? Sorry. And this is, here you will be having the diaphragm. You will be having the diaphragm. Okay. So diaphragm is already a muscular structure. It is having the muscles. So that's what we need to know. Now, bache, the first thing that you need to understand is your inspiration. In the expiration, ultimately, it is going to be the opposite. So first of all, let's talk about the inspiration. So for inspiration, I have few things in my mind, and that is the volume of my thoracic cavity should be more. And now I will use that point. Yes, bacho, now I'm going to use that point, and I hope you already remember that point, right? The one that I just highlighted, right? The one that I just highlighted. So if for inhalation, volume needs to be high, pressure needs to be low. This is first condition. Second condition is, because pressure is low, basically intrapulmonary pressure. So basically pressure is low, volume needs to be high. So intrapulmonary pressure is lower than the atmospheric pressure. Am I right? It is lower than the atmospheric pressure. Am I right? So can I say that it is actually the negative intrapulmonary pressure because it is lower than the, right? It is lower than the atmospheric pressure. So I am saying that it is negative intrapulmonary pressure. Okay. Okay. So now that point is applicable, right? So here I am saying that volume is high and the pressure is low. So now you know that, right? Here, what I have to do for inspiration, right? I need to increase the volume of thoracic cavity, isn't it? I need to increase the volume of thoracic cavity. That will automatically, right? That will increase volume of lung cavity or the pulmonary cavity, isn't it? That will increase the volume of lung cavity or the pulmonary cavity, right? That's why that setup is present in this way. Okay, that's why this setup is present in this way. So increase the volume of thoracic cavity, that will increase the volume of pulmonary cavity. So how that volume will be considered? Increase. So here inspiratory muscles are going to play the role. Which muscles are known as inspiratory muscles? Let me tell you. Which muscles are known as inspiratory muscles, which will contract during inspiration? Which muscles are the inspiratory muscles which are going to contract during inspiration? So during inspiration, it is your external intercostal muscle and the diaphragm muscles that will contract. So which muscles are known as inspiratory muscle? This is also a previous year question. Muscles that contract during inspiration. Muscles that contract during inspiration. That muscles are known as inspiratory muscles, like your external intercostal muscle or your diaphragm muscles. Is that clear? Like your external intercostal muscles and your diaphragm muscles. Fine. And your, yes, bacho, and your diaphragm muscle. Clear? Are you sure? Are you sure? So can you tell me about the okay. Done? So when you talk about this inspiration, more points that you need to note down here is, these points are important for quick revision. So your inspiration is an active process. It will take energy. Inspiration is an active process. It is going to use the energy. It is an energy taking process. Clear, bache? It is going to use the energy. It is an energy taking process, and inspiration is for 2 seconds. This particular process is for 2 seconds. Clear? It is for 2 seconds. Now understand this. I told you that diaphragm is dome shaped. This is what I just said. The diaphragm is dome shaped, right? Like normally, not during inspiration, normally diaphragm is dome shaped. Now first of all, what is going to happen, bache? These diaphragm muscles, they'll contract. So when they will contract, your diaphragm, it will become flat. And this can also be asked as a question, right? This can also be asked as a question. So during inspiration, what is the position of diaphragm? It is flat. It is not dome shaped, it is flat shaped. It is not dome shaped, it is flat shaped. Okay, so initially it is dome shaped, then it will become what? It will become flat. So now imagine, initially that structure was like this. Now because it is flat, so it will be like this. So don't you think that the contraction of the diaphragm muscles will result in increase in the volume? It will result in increase in the volume towards anterior posterior axis. Yes, diaphragm flat muscles. Okay, so they are going to, right? Diaphragm, they will become flat shaped because diaphragm muscles will undergo contraction. So it will, okay, it will increase the volume. It will increase the volume of anterior posterior axis, isn't it? It will increase the volume of anterior posterior axis, isn't it? Isn't it? Yes. Tell me quickly. Right, look at the position now. How are they placed? On the basis of that, you can answer this question. And now, next is your ribs. Now, when you are talking about your ribs, here you will discuss external intercostal muscles. During inspiration, you are going to talk about the external intercostal muscles. And bache, these external intercostal muscles, they will also contract. Fine, they will also contract. And now what is going to happen here? See, imagine, this is the rib cage, right? I hope you guys have seen that lecture, right? When we were taking the marathons for the NEET 2023, right? I was teaching Wazeem sir some dance steps. So this is what we are going to discuss today. See, inspiration is basically this, right? I always explain this topic like that. Inspiration is basically this, right? You have to perform 2 dance steps. The first one is like this. This is the first step. Okay, this is the first step. What is this? What is it signifying? See, diaphragm is dome shaped. During inspiration, it will become flat. Diaphragm is dome shaped, right? During inspiration, it will become flat. And when you talk about the external intercostal muscles, what will they do? Second step is this. Second step is this. First step is this. Second step is this. Right? This is the second step. I'm doing it again. Clear? Clear now what is the meaning of this step? See, when your external intercostal muscle will contract, they will move rib cage outward and upward. They will move your rib cage outward and upward. What will be the movement of what is going to happen when these external intercostal muscles will contract? They will move the rib cage outer side towards the outer side and the upper side. That's why this is the dance step now. Outward, firstly outward, then upward. Outward, upward. That's how you have to remember it. So obviously it will also increase the volume, right? It is also going to increase the volume, and it will increase the volume towards, yes bache, towards dorsoventral axis, right? Dorsoventral lateral axis also you can say. Simply you can say that dorsoventral axis, or you can also say dorsoventral lateral axis. Okay, so that's how overall there is an increase in the volume of the thoracic cavity, right? There is an increase in the volume of the thoracic cavity. So when there is an increase in the volume of thoracic cavity, obviously there will be an increase in the volume of your lung cavity as well. So it means the pressure will become, right? So it means the pressure, what will be the pressure here? It will be negative intrapulmonary pressure. The pressure will become negative, so we are calling it, the pressure will become less, so we are calling it as negative intrapulmonary pressure. So volume is more, pressure is less, air will come in. That is what inspiration is. That's all. That is what inspiration is. Okay, so this inspiration, it is an active process and it lasts for 2 seconds. Fine. This inspiration, it is an active process and it will take around 2 seconds. Got it? Yes, bache. And expiration is going to be the opposite of it. Fine. Right? Whatever is happening in inspiration, expiration will be the opposite of it. So if you understand inspiration, expiration will be very easy then. Okay, expiration will be very easy then. So let me write it down. So during expirations, first of all, the very first thing that you need to remember it is the exhalation. The CO2, we need to throw out the CO2. So volume low, pressure should be high. Okay, so here your diaphragm muscles, again, diaphragm muscles, they relax. Fine, they relax. The volume of anterior posterior axis will again, right, it will again come back to that normal situation. So diaphragm muscle, they will relax. So obviously diaphragm will again become dome shaped. Fine, it will again become dome shaped. And here your expiration, remember, it is a passive process and it will last for 3 seconds. So total in per breath, inspiration, expiration is there, that is for 5 seconds. Fine, that is for 5 seconds. So as I said, diaphragm muscles, they will relax. So again, it will become dome shaped. And your external intercostal muscles, they will also relax. So again, you know that your rib cage, what will be the position of your rib cage? Inward and downward. Initially, it was outward and upward. So inward and downward. So they can ask you this question, which one is active, which one is passive, where will the volume increase, when will the volume come, when volume decrease, what is the position of rib cage, what is the position of diaphragm. So question like this can come in your NEET examination. Okay, question like this can come in your NEET examination. Fine, 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 fine. This is your expiration. Now, one more thing, bache, if it is the forceful expiration, right? Just during exercises or during yoga. Okay, let's take it as a yoga class. What is it? Forceful inspiration now. Forceful expiration. Forceful expiration. Try it. Just try it. Forceful expiration. So forcefully when you expire, when you exhale, then it is an active process. Then it is not passive. Then it is an active process. And here comes the role of your internal intercostal muscles, because they will also contract. Okay, because we have to, this is now forceful expiration. We have to reduce the volume. We have to reduce the volume. We have, we have to reduce the volume. We have to increase the pressure more. Okay, we have to increase the pressure more. So here comes the role of your internal intercostal muscles and your abdominal muscles. Abdominal muscles are going to contract, right? Imagine this is your dome-shaped diaphragm. Abdominal muscles are contracting. So towards this axis, because diaphragm will also move like this. So towards this anterior posterior axis, volume will decrease more. Okay, and internal intercostal muscles will contract. So volume of this dorsoventral axis will also decrease. So during forceful expiration, right, forceful expiration is an active process, bache. So internal intercostal muscles and abdominal muscles also contract. Fine. Internal intercostal muscles and abdominal muscles, they contract. Clear? They are going to contract. Is it clear? Is it clear? Right? So abdominal muscles are having this capability. They can reduce the volume more. They are the additional muscles, right? They have the ability to increase the strength of inspiration and expiration. Okay, so abdomen is having some additional abdominal muscle. This is given in NCERT. So abdomen is having additional abdominal muscle which can increase the strength of inspiration and expiration. So this is about this process. Okay, this is about this process. Fine, so just look at it. This diagram is very good. I know last time also I forgot to share the PDF, but this time definitely I will. Okay, definitely I will. So just look at it. So see, inhalation, active, muscles will contract. Exhalation, passive, muscles will relax. So look at the muscles. So lungs are deflated here, lungs are inflated here, ribs move up and outward, diaphragm is curved down. Here see the diaphragm position. Look at this diagram. It is explaining it completely. Hope you are understanding it. Yes, I hope you are getting it, you are understanding it. Clear? Sure, let's go. So this is the mechanism of breathing. Fine. And okay, right, so this is the mechanism of breathing, and here one point I need to highlight. Okay, so an increase in, so see, so during expiration, see what we have to do, increase in intrapulmonary pressure is required. Okay bache, and we have the ability to increase the strength of inspiration and expiration with the help of additional muscles in the abdomen. Fine. So it is also a previous year question. So this topic is important. This complete topic is important. So inspiration, during which atmospheric air is drawn in. Expiration, when alveolar air is released out. Fine. Fine. So see, there is a negative pressure, negative intrapulmonary pressure when you are talking about the inspiration. So that's what you have to mark. So look at it. We have covered everything. The increase in volume towards the anterior posterior axis and everything we have covered, right? So see, this is written here. Fine, this is written here. So on an average, you know that on an average, a healthy individual we are going to talk about the breathing rate. So see, on an average, a healthy individual, a healthy human being breathes 12 to 16 times a minute. Okay, 12 to 16 times per minute, right? So 12 to 16 times per minute. Are you getting it? Yes. So see now, one cycle is for 5 seconds. So 12 to 16 times per minute. Clear, bache? Sure, sure, sure. And how can you check the volume of air? This is important. How can you check the volume of air involved in these processes? You can do it with the help of spirometer. And let me tell you, bache, right? So spirometer will help you to measure the different volumes in the lung, but not the residual volume. I'll explain it, but do include it in your notes. Not the residual volume. Fine, not the residual volume. Okay. Sure. Fine. So yes, here I am saying the healthy individual is having 12 to 16 times per minute. But in the case of infant, this breathing rate is more. Even this breathing rate is more. Okay, so the next, first of all, just look at these diagrams. So see, diagrams are important. See, during inspiration, diaphragm contracted. These arrows are showing it is coming downward, becoming flat shape. Ribs and sternum, they are raised. Rib cage will go up. So volume here increase. Here, ribs and sternum return to the original position. Air expelled from lungs, volume of thorax decrease. So diaphragm relaxed, it is arched upward. Doubt? Sure? Sure? Okay, so next, this is the topic that we need to discuss, and that is your respiratory volumes and the capacities. And these respiratory volumes, right, we measure them so that, you know, why do we measure them? We measure them so that we can check the health of our lungs. Fine, the functioning of our lungs. Okay, so respiratory volumes, they are measured with the help of spirometer, but your residual volume cannot be measured with the spirometer. I will explain this. Okay, I will explain this. So now we will be talking about the respiratory volume and the respiratory capacities. See, you all have seen these basic phenomena in your day-to-day life. Right, now see, we are talking to each other, right? What are we doing? We are talking to each other. As of now, you know, we are talking to each other. So basically, I am talking to you. It should not be like we are talking to each other. I am talking to you. So all I'm saying is ki without my any extra effort, obviously I am also taking air in and I'm moving the air out, right? This process cannot be stopped, otherwise I'll die, right? It is going on. Fine, I'm talking to you, I'm doing day-to-day activity. At that time also we are breathing, we are taking air in, we are moving air out. Fine. So without our any special effort, this process is going on. Now another point is, now when you are doing some exercise, you know that our breathing rate, it increases. Why? Because we need more oxygen, because metabolism has started, right? Metabolism has boosted, so obviously we need more oxygen there. Fine, this is also the point. Third thing is like obviously yoga. During yoga also, this is what we used to do now. Breathe in, breathe out. So this is the forceful inspiration, forceful expiration is going on, right? You all have seen such kind of activities, isn't it? You all have seen such kind of activities, isn't it? So now the point is the tidal volume. What is the first thing? So basically, of course, it is going to change the volume. It is going to change the volume of air that my lungs are having. If I will do the exercise, yeah, normally I'm moving, yeah, I'm doing some strenuous exercise or something, or any other task, tracking, whatever it is, right? It is going to change that. Okay, it is going to change that. So look at it, tidal volume TV. So it is the volume of air inspired or expired during normal respiration. Normally, air in, air out, air in, air out, air in, air out. So what is the value of it? It is 500 ml. Means with your per breath, right? With your per breath, right? This is the amount of, this is the, if you're talking about the inspiration, 500 ml is the air that you are going to take in. Are you getting it? This is your tidal volume. So this is very important. You need to know about it. Okay, this topic is very important, so please focus here. So what is tidal volume? Volume of air inspired or expired during a normal respiration. Its value is approximately 500 ml. Its value is approximately 500 ml. Now, bache, I have a point. See, you know that on an average, healthy individual is going to breathe for 12 to 16 times per minute. Yes, 12 to 16 times per minute. 12 to 16 times per minute. Now, right, with every breath, if I'm taking 500 ml of air, so means in 1 minute it is going to be, in 1 minute it is going to be, yes, 6,000 to 8,000 ml. That is 6 to 8 liter. That is 6 to 8 liter. Yes or no? Yes or no? Of course. So that is what your tidal volume is. Clear? That is what your, right? That is what your tidal volume is. Clear? Clear, clear, clear? Sure. So this is what you need to remember. Okay, this is what you need to remember. And now we have one more point here. Do you know out of this 500 ml, right? It is not like that if you're taking 500 ml of air within your lungs. So all that amount is available for the exchange, for the diffusion. It is not like that. Literally, it is not like that. Here, bache, near about 30% of the air, that is 150 ml of air, is making the anatomical dead space. Right? It is making that anatomical dead space volume. Yeah, dead air volume it is. It is the dead air. So do you know what is this dead air? What is the meaning of this dead air? Yes. What is the meaning of this dead air? It is anatomical dead space volume. What is it? Anyone? So I am saying that tidal volume, okay, I explained you tidal volume, right? That without, you know, any special effort, this is the amount of air you are taking in or you are taking out, right? Or you are taking out. Yes. So it is 500 ml. So out of that 500 ml, 30% air will be, it is going to form anatomical dead space volume. It is going to form what? It is going to form anatomical dead space volume. Fine. And the remaining air is available for lungs for the exchange. Okay, for the exchange. Clear, bache? So actually this is the air which will stay in your respiratory system, in your this airway, right? It is not available for the exchange or something. Okay, it is not available for the exchange, right? And why is it required? This is what you are going to tell me in the next class. Or sorry, you will put the answer in the, yes, you are going to put that answer in the comment section. That what is the importance here? Why is it so? Why is it so? Okay, yes, this is the amount which is not involved in diffusion. So 500 minus 150, it is going to be your 350. So 350 ml is available. Okay. 350 ml is available. So any doubt here in tidal volume? Understand the tidal volume, then capacities are going to be very easy, right? I was talking to the students of Avengers batch. They were saying, ma'am, this topic is very boring. This topic is not at all interesting, or this is difficult. It's not like that. Trust me, this topic is easy. So tidal volume, if you know about the volumes, then capacities are going to be easy. Capacities will be very, very, very easy for you. Okay? Fine? Okay, so next is inspiratory reserve volume, IRV. Inspiratory reserve volume. Additional volume of air a person can inspire by a forcible inspiration. Forcefully, what amount of air you guys can take in? Okay, forcibly, what amount of air you guys can take in? So that is going to be 2500 to 3000 ml. That is going to be 2500 to 3000 ml, like this. Forcibly, I am taking air in. Clear? Then comes the expiratory reserve volume, of course, right? See, here now I will give you one example and even you guys can relate. So now you know the definition of tidal volume. So forcefully the amount of air that you are taking in. Like it's like that, just as someone, you are visiting a store, okay, right? You are visiting a store, you are going there, and that shop owner is saying, "ठीक है, take whatever you want to take." Right? Let's say you are visiting a store, that can be a jewelry shop, that can be anything. That can be anything. That can be a mobile store, whatever it is. Take it. Imagine wherever you want to go. Imagine the owner of that store is saying, "Do take whatever you want to take." So obviously you will pick up 4 to 5 phones, right? Right? Or the laptops, or whatever you are going to get. You will just take it. Huh? You will just take it, because we are getting something free of cost. So we will take it whatever we can. Same is the case here. You have to take something in. So inspiratory reserve volume. Now expiratory reserve volume. Now let's say if you have to give something back. You have to give something back. It is very difficult for you. It is very difficult for you to give something back. So obviously the amount is going to be less. So it is near about 1000 to 1100 ml. Okay, it is near about 1000 to 1100 ml. Let's say you are going out for a date, right? For a coffee, you are asking your friend, right? You are asking your friend that, okay, please give me some money, right? I want to borrow some money. I want to take my girlfriend or boyfriend to the coffee. So please give me some money. Now that friend is also want to go out for a date, maybe with your partner. Okay, so that friend will be like, okay, now because friendship is there, so that person will be like, fine, I'll give you the money. Right? Because you are asking. But that person is not going to give you the entire money. Okay? Okay. Otherwise, that person will be broke now. And even he wants to go out for a date, for a coffee with your partner. So, of course, that expiratory reserve volume, it is 1000 to 1100 ml. And then comes one more thing, that is residual volume. Like if your friend is asking for the money, no doubt you are going to give that person money, because that's your friend, but you will save some amount for yourself as well, no? Right? You are going to save some amount for yourself as well, no? So that amount that you will save for yourself will be your residual volume. Okay, and it will be 1100 to 1200. Obviously, this is just like your savings. So you will save more, you will give less. So it will be 1100 to 1200 ml. So these are the values that you need to remember. Okay, these are the values that you need to remember. Got it? Sure? Sure? Just a minute. Okay, so that's how you need to remember. So see, so you cannot say that your lungs are without air. No chance. No chance. Always there will be some amount of air in the lungs. That is your residual volume. Residual means remaining. So see, look at the definition here. When it is expiratory reserve volume, additional volume of air a person can expire by a forceful expiration. So 1000 to 1100 ml, right? And then comes this residual volume, volume of air remaining in the lungs after forcible expiration. Like your friend is forcing you to give the money, but you are still not going to give your entire money. Okay, so residual, remaining one. So it is 1100 to the 1200 ml. So only this residual volume, right? With the help of spirometer, you cannot measure this residual volume. Spirometer cannot measure a residual volume. So if you want to calculate the residual volume, what you have to do? You just need to use, right? You will check the capacities. Okay. Right, as per that you will calculate. And do you even know the spirometer? Yes, do you even know the spirometer? That it's a kind of device. 3 balls are there, 3 differently colored balls are there, right? Red, blue or green, and there will be a pipe. You have to blow the air in, right? Right, with the forcibly, and then balls will move up. So it is used to check whether your lungs are working fine or not. And especially, and it is a very good exercise as well. It's a very good exercise. So before surgery, many times doctors, especially to the aged person, doctors used to give them that, please check that whether your lungs are working fine or not. Okay, fine. So that is spirometer. So spirometer cannot measure the residual volume. So is it clear? Right? Is it clear? The value is clear? Yes, the value is clear. Fine. Okay. So now we will talk about the capacities, pulmonary or respiratory capacities. So why they are important? They are important to check the health of your lungs. Fine. Why are they important? They are important to check the health of your lungs. Done, bache? Done, bache? So pulmonary capacities, this is what we need to understand, and it is basically the combination of volumes. If you want to understand these pulmonary capacities, they are nothing, they are just the combination of volumes. Fine. What are they? They are the combination of volumes. Are you getting my point? See, first of all, tidal, inspiratory, expiratory and residual. Now, we are going to talk about the capacities, which are combination of volumes, yeah, addition of volumes. See, what you need to remember here. First of all, just focus here and then we will talk about the definitions. So, here you will talk about inspiratory capacity, expiratory capacity, vital capacity, total lung capacity, then functional residual capacity. Right, it is functional residual capacity. So inspiratory, expiratory, vital, total lung capacity, and then comes the functional residual capacities. Okay, and then comes what? Functional residual capacity. So inspiratory capacity is IC, expiratory EC, VC, and then it is TLC, and finally it is FRC. It is FRC. So do you know there is a very simple trick to remember it? Yes, do you know there is a very simple trick to remember it? See, inspiratory, expiratory, vital, total and functional. So first of all, write down tidal volume, tidal volume, tidal volume, tidal volume. Leave functional residual capacity, because here you are talking about the residual, remaining part. So of course, here firstly you will consider residual volume and you are going to consider expiratory reserve volume. It will be the combination of residual volume plus expiratory reserve volume. But when you talk about other capacities like inspiratory, expiratory, vital, total and functional residual capacities, write it like this: TV means tidal volume, tidal volume, tidal volume, because tidal volume is something basic, right? without knowingly, without putting extra effort, the amount of air you are taking in and taking out. So obviously you have to consider tidal volume. Okay, you have to consider tidal volume. So when it is inspiratory capacity, add inspiratory reserve volume. When it is expiratory capacity, add expiratory reserve volume. Now it is the vital capacity of your lungs. It is the vital capacity of your lungs. So obviously if you are talking about the vital capacity, so I will take inspiratory, expiratory both. Like let's say I want to check your potential. I'm asking, okay, right, I want to check your NEET preparation. So I will ask the questions from physics, chemistry, biology, right? Obviously, so vital capacity is something like that. Now the word is total. So you have to consider everything. So it will be tidal volume, inspiratory reserve volume, expiratory reserve volume plus residual volume. Total will include everything, even the residual volume, And so I can write it like this, that total lung capacity, because this part is equals to the vital capacity. So I can write it like this, simple mathematics, vital capacity plus residual volume. Yes, vital capacity plus residual volume, isn't it? So that's how it works. So these are the volumes and these are the capacities. So capacities are the combination of the volumes. Inspiratory capacity, tidal volume plus inspiratory reserve volume. Expiratory capacity, tidal volume plus expiratory reserve volume. Vital capacity, tidal plus inspiratory, expiratory reserve volume. Total mein you have to include residual volume as well. So you can write it like this also, vital capacity plus residual volume. And then comes functional residual capacity, residual plus ERV. It's that easy, isn't it? It's not at all difficult, bache. It is not at all difficult. As I said, it is just the combination. Fine, it is just the combination. So what is inspiratory capacity? Total volume of air a person can inspire, because it is talking about inspiratory capacity, that what you can inhale, what is the capacity of your lungs, right? What amount of air you can inhale, what is the capacity, that inspiration capacity of your lungs, right? So obviously, how can you check it? When you will exhale all the air. Like if I have to see, let's say I am going to give you a test, right? I want to check your knowledge. So obviously, if you have anything like any book, any notes you have or any books you have, I will ask you, just take that books out, put that books out. There is no need to keep any book, right? Whatever you know, whatever you remember, then only you have to answer the question. The same case here. So if I have to check the capacity of inspiration, if I want to check that what is the capacity of my lungs, what amount of air they can inhale, so I have to remove all the air first, right? So forcibly I have to expire, then I can see actually what amount of air I can take in, okay, right? Not forcibly, normally when I expire, after normal expiration, what amount of air I can take in, that is going to be your inspiratory capacity. So just have a look. So total volume of air a person can inspire after a normal expiration, not forceful, after a normal expiration, right? So then expiratory capacity is opposite. Total volume of air a person can expire after normal inspiration, no difficulty. Even the definitions are easy, don't you think so? Even the definitions are easy, there is no difficulty at all. Next is functional residual capacity, which is saying, next is vital capacity. So vital capacity is saying maximum volume of air, because it is the vital capacity of lungs, right? Like maximum marks you are scoring in your mock test. So maximum volume of air a person can breathe in after forced expiration, or a person can breathe out after forced inspiration. Okay, so that's why we say tidal volume plus inspiratory reserve volume plus expiratory reserve volume. That's making your vital capacity. And when it is total, you know that total volume of air accommodated in lungs at the end of forced inspiration. So that's what you need to remember. So again, you know that it is vital capacity plus residual volume. Fine. So functional residual capacity, so volume of air that will remain in lungs even after a normal expiration. After expiration, what amount of air you hold, that capacity is functional residual capacity. So actually it is easy. Actually, it is easy. If you remember this portion, na, they can even ask you the definition and they can confuse you in between the normal expiration, forceful expiration, normal inspiration, forceful inspiration. But, and if they ask you numerical based questions, so this is what you need to remember. So if you remember the values, you can check it. Like, let's say they can give you, they are not going to give you the formula. NTA will not give you the formula. They will just tell you tidal volume is 500 ml. Inspiratory reserve volume is 1000 ml. Let's say this is what they are giving. So what will be the total inspiratory capacity? 1000 plus 500, 1500 ml it is. So it is a previous year question. Okay, it is a previous year question. So that's your homework. You will solve at least 60 PYQs. Okay, will you do it? You have to solve at least 60 PYQs. Sure? 60 PYQs you have to solve. Fine. So next topic that we need to start is exchange, then transport, and then the disorder, and the topic will be over. Fine, then the topic will be over. Okay? Clear? Sure? So any doubt from the part that we have covered? I hope there is no doubt. CM, you can use the Google as well. So you have to particularly solve questions on capacities and volumes. Some books are having individual questions also, not topic wise questions. So that's what you need to do. Fine, that's what you need to do. Fine, so next part is exchange and then comes the transport. So I am giving you a break. Okay, a break for 10 minutes. And then we will resume. Go to the washroom if you want to, right? Take a stroll, whatever you want to do, just do it. And we will start the class at 7:50. Okay? At 7:50, we will start again. Fine, and then we'll finish it. We need another 90 minutes to finish it. Okay, we need another 90 minutes to finish it. So till then, you have a break. Enjoy your break. Tada. Till then, bye-bye. Hi everyone, welcome back. So now let's continue the chapter and let's talk about the exchange of gases. Okay, so see, when it comes to the exchange of gases, you know that it is the alveoli which are the primary sites for the exchange of gases, yes or no? When it comes to the exchange of gases, so you know that it is the alveoli which is going to be the, yes, it is the alveoli which is going to be the primary site for exchange of gases, yes or no? So now first let's talk about the alveoli, let's talk about the respiratory membrane, and then we will discuss it. Okay, so firstly let's talk about what? Let's talk about the alveoli. And for alveoli we also use the word atria. Okay, we can, yes, we can, this is, so let's start the alveoli first. See, the topic is exchange of gases, and I said that alveoli are the primary site for exchange of gases. So now when it comes to the exchange of gases, it is also possible because of simple diffusion. It is also possible because of the pressure difference, isn't it? It is also possible because of the simple diffusion. It is also possible because of the, yes, because of the pressure difference, isn't it? Isn't it? That is what you know, yes or no? Right, this is what you need to understand, that then only the exchange is possible. So then further the blood will take that oxygen, the blood will take that gases, and the tissues are going to take that oxygen, and tissue will give back CO2, and blood will again bring that CO2 to the heart, heart will pump it to the lungs. That's how it is going to work. Okay, so firstly let me start with that part. See, you know that lungs are there, lungs are the one which are going to add oxygen to the blood, yes or no? Lungs are the organ which are going to add oxygen to the blood, right? So when we talk about the blood, you know that blood is having plasma and it is having formed elements. I always give the example of chocolate milk. Okay, I always give the example of chocolate milk. You can take the example of Bonvita. Okay, so what exactly is happening? Milk is there, milk is there. In that milk you are putting the chocolate powder, right? So obviously even milk will become chocolatey colored, of course. Same is the case here. When you talk about the blood, plasma is making 55% of the blood. Okay, plasma is making 55% of the blood, and when you talk about the formed elements, it is making 45% of that blood. So formed element include your RBC, it include your WBC, it include your platelets, yes, it include your platelets, yes. So plasma, that yellow colored liquid in which formed elements are present, and plasma is mainly what? It is water, water having, you know, some ions, some organic components, hormones for the transport, waste. It is all present here in the, plasma. Okay, so now you must be thinking that, ma'am, why are you telling this? You were talking about the exchange. So let me tell you what is the reason here. So now when it comes to the lungs, as I said, the lungs are going to do the oxygenation. What that lungs will do? Oxygenation, addition of oxygen. So you know that RBCs are red blood cells. Your erythrocytes are going to play the role here. I hope you remember this. Your erythrocytes are going to play the role here. So erythrocytes, right, when they are mature, they are enucleated. They are without nucleus at maturity. So they are without nucleus at maturity. They do not have that mitochondria. They do not have that major organelles like your endoplasmic reticulum mitochondria. They have more space for the respiratory pigment, and that respiratory pigment is what? That is the hemoglobin. So it is actually the hemoglobin which will pick up the oxygen, and it is the one which will help in the transport. Clear, bache? It is the one which will help in the transport. So when lungs, when their alveoli, when they contains the oxygen, so the surrounding blood vessels, if partial pressure of oxygen is low here, right, and here in alveoli, partial pressure of oxygen will be more, right? When we inhale in the alveoli, partial pressure of oxygen will be more, and the surrounding blood capillaries, which will bring deoxygenated blood, they have low partial pressure. So of course, oxygen will move from alveoli to blood capillaries, right, to this blood vessel. And here in alveoli, partial pressure of CO2 is less, but in this blood capillary, it will be more. Okay, so it will move like this. So that's how the exchange will occur. That's how the exchange will occur. So ultimately exchange is also because of diffusion. This exchange is also because of, yes students, this exchange is also because of diffusion. Are you getting it? So now this blood will carry the oxygen, right? How this blood will carry the oxygen? RBC, the hemoglobin there will carry the oxygen. Are you getting it? The hemoglobin there will carry the oxygen. Okay. Okay. The hemoglobin present here, it is going to carry the oxygen. Clear? And then that oxygen, then this blood, see, then next exchange will be there here in the tissues. So tissues are the group of cells. Tissues are the group of cells, yes or no? So here, you know that metabolism is going on. Chemical reactions are going on. Metabolism is going on. Metabolism, which is a defining feature of the living organism. If there is no metabolism in the living body, that living body is not living at all. Okay, okay. So of course here, because of metabolism, carbon dioxide will be released. So tissues are having more partial pressure of carbon dioxide. Now you know why am I using the word partial pressure, right? Because air is a mixture of gas. Each gas is having its own pressure. It is exerting pressure, that is partial pressure. So tissue is having more partial pressure of carbon dioxide. It is having less partial pressure of oxygen. So when the oxygenated blood having oxygen, when it will come to this tissue, obviously again, this is the situation. So the exchange will be done. Exchange again will be done here. So that's how it works. Okay, that's how it works. So ultimately it's all about, ultimately what's that? It's diffusion, right? What is it? It is diffusion. Fine. So whenever you are going to talk about the exchange of gases, ultimately what is it? It is the diffusion. So now I said that it is the alveoli which is the primary site for exchange of gases, right? So firstly, let's talk about the alveoli. So it is the alveoli which is the primary site for exchange of gases. Clear? Clear? So alveoli is a thin sac-like structure, right? What is it? It is thin-walled sac-like structure, right? So when you talk about the lining of the alveoli, bache, right? So here you will see different types of cell. Actually, when you are talking about this alveoli, let me draw the diagram as well. See, if this is that, so when you talk about this alveoli, so bache, it is lined with the simple epithelium. I hope you know this part. It is lined with your simple squamous epithelium. Remember this? Alveoli, it is lined with your simple squamous epithelium. Simple squamous epithelium means, what is the meaning of simple? Simple means it is single layered. Okay, this particular epithelium is single layered. It is not multi-layered. Simple squamous. Cells are flat. They are irregular. They are having irregular boundaries. Okay, and whenever we say simple squamous epithelium, it's a very thin epithelium and it is mainly meant for filtration and diffusion. Fine, it is mainly meant for filtration and diffusion. This is the first point that you need to understand. So alveoli, its epithelium, it contains, right, it is made up of some cells. So majorly you are going to talk about two types of cells here. Type 1 pneumocyte cells. Okay, type 1 pneumocyte cells, and then comes your type 2 pneumocyte cells. And other than these pneumocyte cells, in the alveoli, macrophages, or also known as dust cells, are also present, right? Macrophages and the dust cells are also present. Fine. Macrophages and the dust cells, they are also present. So this type 1 pneumocyte, they are smaller cells. Fine. And type 2 pneumocytes, they are larger cells. Type 1 pneumocyte, it is the smaller cell. Type 2 pneumocyte, it is the larger cell. So when you talk about this type 1 pneumocyte, which is a smaller cell, okay, which is a smaller cell, it is meant for exchange of gases. right? In this alveolar epithelium, we have two types of cells mainly, right? Type 1 pneumocyte cell, which are smaller in size. So they are meant for exchange of gases. Clear? They are meant for exchange of gases. And bache, when you talk about these type 2 pneumocyte cells, which are larger, okay, so these cells, yes, these cells, they are going to form the surfactant lecithin. They will release the surfactant lecithin. Remember lecithin, it is a phospholipid. Okay, so type 2 cells, they will secrete a phospholipid. They will secrete a phospholipid lecithin. So yes, this phospholipid lecithin is present in the lungs. Okay, this phospholipid lecithin, it is present in the lungs. Clear? So please note down the function of this lecithin. It is a surfactant. What is it? Right, it is covering these alveoli. What is this lecithin? It is a surfactant. Wait, we'll try to write it here. It's a surfactant, and bache, it reduces the surface tension. Okay, so what is the function of this lecithin? It is going to reduce the surface tension. Surface tension of what? Surface tension of alveoli, of course. Okay, so that alveoli, they remain always open for the exchange of gases. This is what you can note down. So it is a surfactant. It is a surfactant which is going to reduce the surface tension of the alveoli and keep alveoli always open for gaseous exchange. Right? So it is going to keep alveoli always open for gaseous exchange. Please note down. So I'm repeating this again. Lecithin, surfactant which reduces the surface tension of alveoli so that alveoli remains open for efficient gaseous exchange. Clear? So that is the role of this surfactant. And as I said, bache, macrophages or dust cells are there. So you know that what is the role of these macrophages or dust cell? They will destroy the foreign particle. They will destroy the dust particles there. And bache, these alveoli, in both the lungs, 300 million alveoli are present. Okay, they are present in both the lungs. Clear, bache? They are present in both the lungs, 300 million alveoli. Is that clear? So this is the alveoli. So alveoli is having simple squamous epithelium. That's what you need to remember. Now, let's talk about this blood vessel. It is blood capillary. Actually, bache, you can even note down here that alveoli, they are highly, see, as I said, na, they are thin-walled sac-like structure. They are, here I'm writing it. They are highly vascularized. What are they? They are highly vascularized. What is the meaning of highly vascularized? Highly vascularized means they have abundant blood supply, right? They have abundant blood supply. So when we talk about the exchange of gases, your capillaries, because they have very thin wall, right? They have very thin wall. They are meant for exchange of gases. Just in our body, we have arteries. Arteries will form arterioles. Right, that arterioles, you have great large blood vessels which are going to form arteries. Arteries will form arterioles. They will form capillaries. Like your veins will form venules, like this. Okay, like this. Clear? So alveoli, and here you have the blood capillary. So blood capillary is also lined with a type of simple squamous epithelium. It is also lined with the type of simple squamous epithelium, and it is known as endothelium. So mesoderm is going to form this endothelium, right? So it is the endothelial layer of the blood capillaries. One is the simple squamous epithelium of alveoli or of alveolar. It is alveolar epithelium is simple squamous, and this blood capillary epithelial is made up of endothelial cells. So if you have revised structural organization in animals, you know it very well that they lie on, right? These cells, they lie on acellular basement membrane. How many of you remember it? That these cells, they lie on acellular, right? These cells, they lie on acellular basement membrane, right? Is that clear? Right? So even your epithelial cell, this simple squamous epithelium is laying on the basement membrane, and this one also. So basement membrane is acellular, means it is non-living. So alveoli, blood capillary, and here in between you have the interstitial space. Here you have the interstitial space. So this structure is actually the respiratory membrane, bache. Okay, this structure is actually the respiratory membrane, okay, through which the exchange of gases is going to take place. So look at the partial pressure and look at that arrow. Okay, so these three layers are making the respiratory membrane. Simple squamous epithelium of alveoli, endothelial of blood capillary, basement membrane present in between two. These three are making the respiratory membrane, and the thickness of respiratory membrane is less than 1 mm. Always remember this. Respiratory membrane, its thickness is less than 1 mm. It should be less than 1 millimeter. Okay. Okay, this is what respiratory membrane is. So exchange will take place along it. So alveoli is having more partial pressure of oxygen. Oxygen will go here, CO2 will come here. That's how it occurs. And bache, this particular exchange, it is actually the external respiration, because air is directly coming, right? Air is coming within our lungs, and from alveoli they will pass to the blood. Right here, actually it will come in that body contact, that exchange will occur. So this step, the exchange of gases in between alveoli and blood capillaries, this is the external respiration. Please write down. Okay, please write down, this is the external respiration. Okay, so as I said, alveoli, they are the primary site for exchange of gases. I have discussed the structure of alveoli as well. So exchange of gases which occur between blood and tissue, you know that. So oxygen and CO2 are exchanged. So this exchange, it depends upon the pressure gradient. You know, simple diffusion is going on, Subhashini. You know it very well. Diffusion is going on. So it depends upon, please write down, right? Please write down. The first factor is pressure or the concentration gradient. I told you this thing before. It depends upon the pressure and the concentration gradient. Clear, bache? Clear, bache? Second point is the solubility of the gases. Second point is the solubility of the gases. Just for an example, CO2 is 20 to 25 times more soluble in plasma than oxygen. Do you know that? Solubility of carbon dioxide is more than that of oxygen. Solubility of CO2 is more than that of oxygen. Okay. Okay, so first is pressure or concentration gradient, second is the solubility of gas and solubility of the gases, and the third main important reason is thickness of the membrane. Okay, so thickness or thinness, whatever you want to write. So the membrane should be thin. Okay, so this respiratory membrane through which the exchange of gases will occur, it is less than 1 mm. Fine, it is what? It is less than 1 mm. Is that clear? It is less than 1 mm. Okay. Okay, so that's what you need to remember. So bache, this pressure contributed by individual gas and mixture is partial pressure. I hope you remember it. So now this is the table that you need to remember. This is important for your NEET examination. Okay, this is important for NEET. Clear? It is very important for NEET. So let's discuss it. So respiratory gas, oxygen, respiratory gas, CO2. Okay, so focus here, you need to remember it. So see, the partial pressure of oxygen in atmospheric air is 159 mmHg. Just look at it. It is 159 mmHg. But in alveoli, it is 104. Means in atmosphere, the pressure is, partial pressure is 159 mmHg. But in the alveoli, it is going to be 104 mmHg. Why such difference is there? Can you explain me the reason? Ultimately, it is the atmospheric air which we are going to take in. Can you explain me the reason here? Can you just explain me the reason here that why atmospheric air and its partial pressure is more, then the partial pressure of oxygen in alveoli. Yes, then the partial pressure of oxygen in alveoli. Anyone in the class? You need to remember these values. This table is important. This table is important. You need to remember these values. Anyone? But you see, when air will come in, right? Here initially in the airway, that air will be humidified, like water vapors are going to be added. Water vapors will be added there. It is going to affect the partial pressure. It is going to affect the partial pressure. Moreover, this air will get mixed with that dead, anatomical dead air space volume. Yes, it is going to mix with that dead air space volume, right? So both the things are going to, these things are going to affect this partial pressure of oxygen, right? These things are going to affect the partial pressure of the oxygen. Are you getting it or not? Quick, this part is important, bache. This part is important. Can you see that? 159 and then here it is 104. Right? Then it is 104. Why? Why is it so? Why? Because, bache, right, inhaled here, air, it will get mixed with that dead space air, right? It will get mixed with that dead space air, and moreover, it will be humidified. It means, right, and yes, it is humidified as well. Water vapors are added, dead air space volume is there. It will mix with that air, and even residual volume is there, no? Residual air is also there. Residual air is also there. Imagine it, like no doubt we are going to inhale. Okay? Outside the partial pressure of oxygen is this. But in this alveoli, you have some amount of CO2 as well. Even if it is less, you have that. Right? You have that. But overall, if I have to say, you know that in our lungs, we have the residual volume of air. Basically, residual air is also there. That dead space air is also there. So when we inhale and when all the things get mixed, the partial pressure of alveoli, it came down. Okay, it will came down. Dead air space volume, bache. Dead air. Well, I hope you have followed the lecture since we started. Then you will get it. Okay, so that's why there is a difference here. And if there is any other reason, you will check it and you will let me know, right, in the comment section. Fine, in the comment section. Now look at the partial pressure, right? Now look at the partial pressure of deoxygenated blood. See, understand this part. We are talking about the oxygen, right? And now we are talking about the deoxygenated blood. Deoxygenated blood, usually what we understand from this term, that this blood is not having oxygen. But it is not the literal meaning. This blood is not having, right? This blood is not having oxygen. That's what we are saying. No, it's not like that. Actually, in deoxygenated blood, the partial pressure of oxygen is less. That's the meaning. Right? The partial pressure of oxygen is less here. Are you getting it? The partial pressure of oxygen is less here. So it is 40 here. And if you will compare it with the oxygenated blood. So oxygenated blood is the one having more partial pressure of oxygen. Right? Deoxygenated blood is the one where the partial pressure of oxygen is less. So tissues are also having less partial pressure of oxygen. Then only exchange is possible. Now compare it, like oxygenated blood is having 95 partial pressure, tissue is having 40. Obviously, oxygen will jump from that blood vessel to the tissue. Oxygen will jump from that blood vessel to the tissue. Now compare it with the carbon dioxide. So carbon dioxide, atmospheric air, its partial pressure in atmospheric air is very less. And in alveoli, because of metabolism, it is more, 40. In deoxygenated blood, the partial pressure of carbon dioxide is more, 45. And partial pressure of oxygen is less, right? And the tissue is having 45. So yes, you need to remember these values. Clear, bache? You need to remember these values. And let me tell you, right? Okay, yes, you need to remember these values. Clear, bache? So if you remember this, then everything will be clear. Now let's discuss this particular part. But before that, see, now you know that we have the heart, which is the pumping organ. Okay, now we have the heart, which is the pumping organ, and this human heart is 4-chambered. Yes or no? This human heart is 4-chambered. Yes or no? We have a heart is 4-chambered now. We have two auricles and two ventricles. This is the right auricle, right ventricle. This is the left auricle, left ventricle. And here you have the heart. And let's say here you have the lungs. So ultimately lungs are going to do the oxygenation of blood. What is the meaning of oxygenation? Addition of oxygen. What is the meaning of oxygenation? Addition of oxygen. So basically here, just remember one trick. I'll use it twice. The trick is Lord. What is the trick? The trick is Lord here. Right? What is the trick? Yes, everyone. It is Lord here. So L stands for left. O stands for oxygenated. That is, left side of the heart is having oxygenated blood. So the right side of heart is having deoxygenated blood. Okay, right side of heart is having deoxygenated blood. This is what it means. So ultimately, bache, what is happening actually? The right side, right auricle will receive deoxygenated blood, will give it to right ventricle. We will discuss it in next chapter, that is body fluid and circulation. So from right ventricle, your deoxygenated blood will pass to the lungs. That's a fact. Yes or no? See, I hope you know about it. If not, please note down. Arteries, they used to carry oxygenated blood. Right? We have one exception, that is your pulmonary artery. That used to carry deoxygenated blood. Arteries used to carry oxygenated blood, but here we have one exception, and that is your pulmonary artery, which used to carry deoxygenated blood. Okay, same way we have the veins. Veins used to carry deoxygenated blood. They used to carry deoxygenated blood. So here what is the exception? Here what is the exception? Pulmonary vein. It is going to carry oxygenated blood. Clear? It is going to carry oxygenated blood. Right? So right auricle, right ventricle is there. So from right ventricle, your pulmonary, okay, from right ventricle, your pulmonary artery will carry deoxygenated blood towards the lungs. Okay, it will carry deoxygenated blood towards the to the lungs. So lungs are going to, here, because of that partial pressure difference, exchange will occur. So your lungs will carry, right, lungs will bring that oxygenated blood to the right side of the heart, and then it will pass to left ventricle. Left ventricle, with the help of your systemic aorta, or you can say that aortic arch, it will carry it to the different parts of the body, different part of the body organs, right, bache? So ultimately that's how the exchange will go on, right? That's how the exchange will occur. So I hope now you can understand this part. See, here you can see the alveoli where actually the exchange will occur. You know, na, pulmonary artery will carry deoxygenated blood from the right side of the heart towards the lungs. So because of this partial pressure difference here and here, right, this exchange will occur. Now pulmonary vein will carry oxygenated blood to the left side of heart, and from here, from left ventricle, with the help of these systemic arteries, you can also call it as aortic artery or aortic aorta, it will carry it to the different parts of the body, where again the exchange will occur because of the difference of this partial pressure. Doubt? So when it is the, see, systemic veins, they carry deoxygenated, arteries, they carry oxygenated blood. So look at the difference in the partial pressure here. In the veins, in the deoxygenated blood, partial pressure of CO2 is more and the partial pressure of oxygen is less. Here, when it is oxygenated blood, partial pressure of oxygen is more, partial pressure of CO2 is less. So this comparison can be asked, this diagram can be asked. But you can use any module, and number of lessons, you can just visit the channel and you can check it. Okay, Gopika Shri, that's how you can check it. Is that clear, bacho? Sure. So that's what you need to remember. And you know what? When do we inspire? When do we inhale? Do you know that when inhalation occurs? See, when in arteries, the partial pressure of CO2 increases, it sends a signal to brain. Okay, it is going to send a signal to brain and the inspiration starts. Clear, bache? Inspiration starts. Fine. Okay, and the inspiration starts. So always remember this is very crucial, right? In our body, if partial pressure of oxygen is less, it is not going to initiate inspiration. Actually, if in arteries, see, this point is very important. If in arteries which used to carry oxygenated blood, but if here the partial pressure of CO2 increases, it sends a signal to brain. Now it's the high time, go for the inspiration. Okay, go for the inspiration. So that's what you need to remember. Fine, that's what you need to remember. And remember, solubility is having more, carbon dioxide is having more solubility, 20 to 25 times it is more soluble than oxygen. Right, so that's what we have discussed. So now let's read it from NCERT once. So see the diagram, alveolar cavity, air is coming. So it is made up of squamous epithelium. Right, here you have endothelial cells of blood capillary, basement membrane present in between two. Right, and this is showing RBC. So they can put this diagram in the final paper and they can ask you the question. Okay, okay, so see, solubility of CO2 is 20 to 25 times higher than that of oxygen. So amount of carbon dioxide that can diffuse through diffusion membrane per unit difference in partial pressure is much higher than that of O2. Now, what is the meaning of this particular line? What is the meaning of this particular line? It's very simple. See, I told you initially that whenever we talk about the diffusion, that's what we just discussed, right? That whenever we talk about the diffusion, the solubility of gas is also a major factor. That's what we discussed, right? Whenever we talk about the diffusion, the solubility of gas is a major factor. It's an important factor. So here, I am saying that carbon dioxide is more soluble than the oxygen. This is a very important question. Right? It can come in final exam as well. Fine. So CO2 is more soluble. Carbon dioxide is more soluble. It is, see, as the solubility of CO2 is 20 to 25 times higher, it is more soluble. Now, how is it going to affect? At a partial pressure, right? Let's say you have kept the same partial pressure, but still your CO2 will diffuse more through this respiratory membrane or through this diffusion membrane. Okay, it will diffuse more. Okay, okay. So the amount of CO2 that can diffuse through diffusion membrane per unit difference in partial pressure is much higher as compared to the oxygen. So solubility, in this way, solubility plays the role. Fine. In this way, solubility plays the role. Clear, bache? So diffusion membrane, I told you already, 3 major layers are making it, right? One is your thin squamous epithelium of alveoli. Second is your endothelium of alveolar capillary. And third is the basement membrane present in between, which is supporting these layers. Okay, so its thickness is much less than a millimeter. Okay, so all the factors of our body are favorable for diffusion of oxygen from alveoli to tissue and CO2 from tissue to alveoli. Doubt? Yes, doubt? Any doubt? So this is about the exchange. Okay, so next is about the transport. So firstly, tell me exchange clear, diffusion membrane clear. This table is important. Question can come from this part. Okay, question can come from this part. So now when it comes to the transport of gases, obviously blood will carry the gases and then there will be the exchange, right? But how? How will it take place? Now NCERT is the main book that we have to follow here. See, blood is the medium of transport. You know na, blood is our vascular connective tissue which is going to transport everything. It is the vascular connective tissue which is going to transport everything. So about 90% of the oxygen is transported by RBCs. Right, and the 3% will be in the dissolved form. So the first thing that you need to understand is transport of oxygen. The very first thing that we need to understand here is the transport of oxygen. What is it? It is the transport of oxygen. See, okay. As I said, 97% of oxygen is transported in the form of oxyhemoglobin. Remember this. In the form of oxyhemoglobin, and 3% is in dissolved form and 3% is in dissolved form in plasma. That's important information. Clear? That is an important information. Clear? That is an important information. Tell me, is it clear? So 97% will be transported by RBCs in the form of oxyhemoglobin, and the remaining 3% in the form of, in the dissolved form, right bache, it is dissolved in the plasma. Okay, so now we need to understand few points here. See, as I said, your blood, I'm repeating this part, is having plasma and formed elements. That's what I just said. Blood is having what? It is having plasma and formed elements. Formed elements means, like I gave you the example of the milk and the chocolate powder. Chocolate powder, when you will dissolve the chocolate powder in milk, milk will become chocolatey, isn't it? So that chocolate powder is nothing, it is the formed element. So here, which formed element, which cells do we have? We have RBC, red blood cells, WBCs, white blood cells, also known as leukocytes, platelets meant for clotting, thrombocytes. Okay, right, they are thrombocytes. Clear? So here we need to know about the RBCs. Okay, we need to know about the RBCs, red blood corpuscles, also known as erythrocytes. So now when you talk about these erythrocytes, in detail about these erythrocytes, their amount, we will discuss in body fluid and circulation. But let me tell you, right, you know their average lifespan is near about 120 days or 120 to 125 days. Okay, okay. So these RBCs at maturity, they are enucleated. Clear? They are enucleated, and in the case of humans, their shape is biconcave. Okay, right? What type of shape do they have? They are enucleated, they have biconcave shape. Right? They are enucleated, they have biconcave shape. Clear, bache? So now if they are without nucleus, they do not have the nucleus. They do not have the nucleus. They do not have this mitochondria, endoplasmic reticulum. They do not have this. Bache, Jyoti, albumin helps in maintaining the osmotic concentration, not in the form of this transport. Okay, it will maintain the osmotic concentration. So, enucleated biconcave RBCs are present in the mammals. Okay, in the mammals you will see they are without nucleus at maturity and they are having biconcave shape. But you have exception, right? You have exception. The exception is your camel and llama. And here you will see that RBC is with nucleus even at maturity and the shape is biconvex. It is basically, yes, it is having the biconvex shape. Okay, so kind of oval kind of shape is there. Okay, having the oval kind of shape is there. This is what your RBC is. Fine. So I will explain few points related to the RBCs. Now RBC is without nucleus. It is without organelles. Actually, RBC is a very noble guy. RBC is like here, I am meant for the transport of gases. Okay, I am meant for transport of gases. This RBC is fully loaded with hemoglobin, which is our respiratory pigment. Okay, so RBC is like if I will keep organelles, other organelles, they will also demand for oxygen. For their activity, they also need oxygen. So I am not going to keep anything. I am not even going to keep the nucleus as well. Okay. Okay, I will be dependent on glycolysis only. You know, the first step of respiration is glycolysis, which is anaerobic respiration where breakdown of glucose in the absence of oxygen will be there, and that is going to form the pyruvate. Let me teach you other chapters, the human plant physiology. So there comes a time till December you all will be like, here ma'am, now let's not say botany, zoology, it's biology and we are understanding everything. Okay. Okay, so hemoglobin is present here in this RBC. So because other organelles are not there, so now they have enough space. RBC is having enough space, so it is going to load all the hemoglobin here. It is fully loaded with the hemoglobin, isn't it? It is fully loaded with the hemoglobin, isn't it? Now what this hemoglobin is going to do? What is exactly this hemoglobin? You know that, right? Hemoglobin is a quaternary protein. What is it? It is a quaternary protein. Yes or no? Yes or no? Means it is having 4 polypeptide chains. Right? It is having how many chains? It is having 4 polypeptide chains. Clear? Clear? So one chain, see, all of them are kind of tertiary. They are, you know, spherical. They are so folded. So hemoglobin is a quaternary protein made up of 4 polypeptide chain. So if I talk about the adult hemoglobin, it is having 2 alpha, 2 beta chains. It is having 2 alpha, 2 beta chains. Remember this part, right? And here, bache, globin is the protein part. Globin is actually that globin word here, right? Globin word written here. Globin is actually the protein part. That heme is the pigment. So we'll just look at these 4 polypeptide chains, right? So this structure, this one, this is your heme. It contains iron. It contains iron. And do you know the iron is present in which form? Do you know iron is present in which form? It is Fe2 plus. Fe2 plus. So this heme contains this iron. Okay, it is having this iron, Fe2 plus. Clear, bache? So this is one hemoglobin having 4 polypeptide chains. Are you getting it? This is one hemoglobin having 4. It is made up of 4 units. Each unit is having 1 iron in +2 state. Clear? So it is ferrous, right? If I'm not wrong, it is ferrous, right? Right? It is ferrous or ferric? Fe2 positive. Is it ferrous or ferric? Which ionic form it is? Is it ferrous or ferric? Two alpha, 2 beta chains are there. 2 alpha, 2 beta chains are there. I told you, 4 chains. 2 alpha, 2 beta. By mistake, I wrote it as 3, but it is 2. 2 alpha, 2 beta chains. So it is ferrous form. So see, hemoglobin is having 4 units. It's a quaternary protein. It is having 4 units. So here iron is present in +2. This is the oxidation state here. So it is the ferrous, right? So each Fe2 positive can bind with 1 oxygen. Each Fe2 positive can bind with 1 oxygen. So can I say that when this hemoglobin is fully saturated, what is the meaning of fully saturated? Like when hemoglobin has acquired, fully saturated means that all the ferrous ions, they are joined with the oxygen. They have picked up the oxygen. So can I say that 4 oxygen molecules will be picked up by this? This reaction is justified or not? Yes, tell me, is it justified or not? This is happening in alveoli, na? In alveoli, right, oxygenation is occurring. So basically your hemoglobin having, it is made up of 4 units. It is having 4 polypeptide chains, and here each chain is having 1 ion. So each ion can bind with oxygen. So when hemoglobin is fully saturated, when it is fully saturated, right, when all the ions are attached to the oxygen, so this will be the stage. This will be the stage. So here this is your oxyhemoglobin. Hemoglobin is attached to the oxygen. Okay. Okay. So 97% of oxygen will be transported in this way. So when oxygen, it is attached, when hemoglobin is attached to oxygen, it is forming oxyhemoglobin. Okay. It is forming oxyhemoglobin. Is it clear? First of all, tell me, is it clear? Yes or no? This reaction, this part clear? The hemoglobin, the quaternary structure, total 4 chains are there, 2 alpha, 2 beta chains are there, right? So this is the reaction here. So hemoglobin will join with oxygen and they are going to form the oxyhemoglobin. Now, bache, this is the oxygenation. It is not oxidation. Many times you confuse this part. It is oxygenation. Oxygenation means addition of oxygen. You have added the oxygen. When you are saying oxidation, you know, no, oxidation, loss of electrons, right? When your glucose will be oxidized, ultimately we are breaking it. We are releasing CO2 and water. Here we are saying oxygenation, addition of oxygen. So when oxygen will be added to hemoglobin, this is oxygenation. Oxygen is added to the hemoglobin. It is oxygenation. And this oxygenation here, right? See, this oxygenation of hemoglobin, and then it will form oxyhemoglobin, of course. So this oxygenation of hemoglobin is what? It is, bache, temporary. Important it is, huh? It is temporary. It is reversible. This addition is temporary. This is a reversible. This addition is what? It is temporary and reversible. What is it? Yes, everyone, please explain. What is it? It is temporary and reversible. Repeat it with me. Repeat it with me. It is temporary and reversible. Is that clear? Is that clear? It is temporary and reversible. Temporary and reversible. So it is oxygenation, not oxidation. This word is important, right? So why is it so? जैसे these days love stories, they are quite temporary, right? जैसे let's say कि this year you are roaming with one person, next year you will roam with another person, है ना? These days love stories are like that. Any reason can be there. I'm using this particular thing to explain my concept. Now, you know that we have to transport the oxygen to the different tissues. Yes or no, Priyanka, Ishwat, Vidisha, Nandini, Sahiti, Jyoti? This is what we need to do. What we need to do? We need to transport the oxygen. We need to transport the oxygen to the different cells, to the different tissues, because they need it. Why do they need it? They will use that oxygen for cellular respiration. They will use that oxygen for oxidizing glucose so that they can get energy. So transport of oxygen is important, and we are using hemoglobin as a medium, as a vehicle. Okay. Let's say you have to go to a place. You will take the bus, car, flight, whatever it is. Then you will go to that particular place, isn't it? Isn't it that temporarily you are in that particular car or something? No, it is not like that you will start living there. Of course not. Same is the case here. So if I'm using hemoglobin to transport my oxygen to the different parts of the body, so whenever I will add oxygen to the hemoglobin, I should make it temporary and reversible. If it will not be, if this relationship will be permanent, my body organs, they are not going to get the oxygen. My body cells are not going to get the oxygen. They will just wait for the oxygen and they will die. Without oxygen, we cannot survive. No. है ना? So here, this relationship needs to be temporary and reversible. This is something very important. Then only the oxygen can be transported. Otherwise, the hemoglobin and oxygen will stay together and cells will die. This point clear? This point clear? Now, how this oxygenation will occur? What are the factors that are favoring the oxygenation? What are the factors that favors oxygenation? Let's talk about it. Don't you think that partial pressure is something very important? Don't you think that partial pressure is something very important? जैसे यार hemoglobin is like this. Hemoglobin is like यार sometimes hemoglobin is with oxygen. Sometimes hemoglobin is with H positive ions. Yes, you heard me right. Hemoglobin also bind with H positive ions. With H positive ions and form hemoglobinic acid. Okay, it forms hemoglobinic acid. So all I'm saying here is that hemoglobin is sometimes hemoglobin is with carbon dioxide. Sometimes hemoglobin is with oxygen. Sometimes hemoglobin is with H positive. Right? जैसे you know ना, siblings are younger siblings, they are like that. If you have something to offer them, then they are in your team. Otherwise, they'll leave your team. है ना? Otherwise, they'll leave your team. Same is the scenario here. Same is the case here. Okay. So if the partial pressure of the oxygen will be high, then hemoglobin is attracted towards the oxygen. Then hemoglobin will be like, oxygen, please be my friend. Right? Let's favor the oxygenation. You please be with me, because at that time, partial pressure of oxygen is high. Okay, so this is the main point that you need to remember, that factors that favor oxygenation includes high partial pressure of oxygen. So if partial pressure of oxygen is high, so definitely the partial pressure of carbon dioxide will be low. It will be low. Here it will be high, so of course it is low. And when bache CO2 is low, partial pressure of CO2 is low, actually your carbon dioxide with water, it will form carbonic acid, and that carbonic acid will further form bicarbonates and H positive. Do you know that? It will further form bicarbonates and H positive. We will discuss about it as well. So ultimately, I'm trying to say that when CO2 is high, then it increases the H positive, it decreases the pH. But now here, because CO2 is low, so less H positive concentration will be there. If hydrogen ions are less, means acidity is less. Many times students, they confuse this high H positive, low pH, high pH. They confuse it. So now listen to me. If H positive is less, H positive less means less acidity. Acidic conditions are not there. So if acidic conditions are not there, the pH will be high. High pH means basic pH. Alkalinity it is not. So above 7 it will be 8, 9, 10, 12. They all are what? Basic pH. So when the pH is low, it means acidic conditions are there. It means acidic conditions are there. So if acidic conditions are there, Hanji, low pH means acidic conditions are there, yes or no? Acidic conditions are there, yes or no? Of course, yes, na. So they are only possible when H positive is high. More H positive means more acidity means pH will be low. But now here what am I saying? I'm saying that less H positive, so it means high pH, and then the temperature will also be low. So these are the conditions for the oxygenation. These are the conditions that favor oxygenation, means addition of a temporary and reversible addition of oxygen to the hemoglobin. So in the lungs, in the alveoli, this condition you are going to see. Okay, this condition you are going to see. Is that clear? Is that clear, bache? We need to talk about the oxygen dissociation curve, and even we need to discuss about the yes, Bohr's effect. So you better tell me if it is not clear. I'll explain it again. Do let me know. Do let me know. Okay, do let me know. If there is doubt, do let me know. Fine. Okay. Done. And bache, here one more thing is there. It is not given in NCERT, but it is your 2,3-DPG, that is diphosphoglycerate. It will form during glycolysis. Phosphoglycerate. Okay. So when there is the addition of oxygen, right, you will even notice that there is the low concentration of 2,3-DPG, that is diphosphoglycerate. Right, that is diphosphoglycerate. So first of all, tell me this part clear. But your temperature will be low at that time. Okay, addition is going on. See, when metabolism is there, when metabolism is going on, reactions are going on, energy will be released. Temperature, obviously it is related to the temperature. Metabolism, chemical reactions, and during metabolism, waste gas CO2 will be released. This is what you know. So here, because addition is going on, right, basically addition is going on, so at that time the temperature is low, and these are the condition that favors the oxygenation. Okay, these are the condition that favors the oxygenation. So this is what we are discussing. Okay, so this is what we are discussing, transport of oxygen, right? So we are saying that oxyhemoglobin will form, that is oxygen and hemoglobin will get attached. So it will be in a reversible manner. This arrangement is temporary. Okay, okay, and this binding is basically related to the partial pressure, right? Each and every line written in NCERT, we are discussing each and every line written in NCERT. Okay, so partial pressure of CO2, H positive, temperature, they are the factors which interfere with this binding, and this curve can explain it. Fine, this curve can explain it, and you know that it is the oxygen hemoglobin dissociation curve. What is it? It is oxyhemoglobin or oxygen hemoglobin dissociation curve. Now this is what I am going to explain, and with the help of this curve you will even understand the Bohr's effect. Okay, you are even going to understand the Bohr's effect with the help of this curve. Done? And yes, I was telling you about the surfactant. The notes I will share. I was telling you about the surfactant. Now see, I have added beautiful diagrams as well. Firstly, have a look. See, I told you alveoli type 1, type 2 cells are there. So type 2 cells are going to release the surfactant, okay, which is your lecithin, right, which will cover your alveoli so that it can reduce the surface tension, and it will stay like that, so and the exchange of gases will occur. This point clear? Look at this diagram. Is it clear? Is it clear? So next is this part that we are discussing. I need a after explaining it now, I will use that NCERT snip. As of now, I just need this diagram. Okay, so oxygen hemoglobin dissociation curve it is. Oxygen hemoglobin dissociation curve it is. Isn't it? Isn't it? है ना? Or oxyhemoglobin dissociation curve. Firstly, just look at it. I will explain what is going on, but just look at it and tell me what you guys can depict. One thing, that this curve is S-shaped. It is sigmoid in nature. This curve is S-shaped and it is sigmoid. Sigmoid means that S-shaped. Now, another important thing that you need to notice here is that, see, x-axis is representing partial pressure of oxygen in mmHg, and this y-axis is representing percentage saturation of hemoglobin. Y-axis is representing percentage saturation of hemoglobin. Clear? Clear? Is it clear? Yes or no? I think one thing is very clear in your mind, that it is the hemoglobin which will carry the oxygen. 97% of the hemoglobin. And yes, how can I forget? Overall, if I talk about the transport of this oxygen, only 97 in total. Right? In totality, only 97% of the oxygen will be, transported. Right? And out of that 97%, the 97% of that 97% will be transported in the form of oxyhemoglobin. So, ultimately, when you talk about 100 ml of blood, I'm saying this under normal physiological conditions. Okay? It is under normal physiological conditions. Why? It is under normal physiological conditions. Okay? Okay. So under normal physiological conditions, see, 100 ml of blood. Do you know that when we go for blood test, they check our hemoglobin. They used to tell us it in grams. Yes or no? They used to tell us it in grams when we go for the blood test to check whether we are anemic or not. I hope you know about it. So basically they check the amount of hemoglobin in 100 ml of blood. Do you know that? In 100 ml of blood. So on an average, in adult individual, we consider that 100 ml of blood is having 15 gram of hemoglobin. You know that it varies. You know that in the case of females, this amount is less. In the case of males, it is more. है ना? In the case of females, it is less. In the case of males, it is more. But on an average, an healthy adult contains 15 gram of hemoglobin in 100 ml of blood. Fine? Fine. With this part, I will explain about the partial pressure difference. I'll explain very important thing with the help of it. So you better listen to me very carefully. Fine? 100 ml of blood is having 15 gram of hemoglobin. And do you know 1 gram of hemoglobin? When it is fully saturated means all the 4 ions are attached to oxygen. All the 4 ions are attached to oxygen. So 1 gram of hemoglobin can transport 1.34 ml of oxygen. Do you know that? 1 gram of hemoglobin means all the 4 ferrous ions, they are attached to the oxygen. So they have, okay, so 1 gram of hemoglobin, yes, it binds to, right, 1 gram of hemoglobin, it binds to 1.34 ml of oxygen. So obviously, bache, 15 gram of hemoglobin will bind to, 15 grams of hemoglobin will bind to, multiply it, 15 into 1.34. So it will be near about 19.4 ml. So approximately, can I say that it will be 20 ml of oxygen? Can I say that it will be 20 ml of oxygen? Yes or no? Yes or no? So with the help of, so it is a, see, these are the normal physiological conditions. These are the normal physiological conditions. So can I say that 100 ml of 100 ml of blood contains 20 ml of oxygen? Yes, 20 ml of oxygen. 100 ml of blood contains 20 ml of oxygen. So it is the data when my blood is oxygenated. So in another way, how can I define this part in another way? that per 100 ml of, see, I'm just changing the language so that you don't get confused. So 100 ml of oxygenated blood, 100 ml of oxygenated blood contains 20 ml of oxygen. Fine, 20 ml of oxygen. And now when they measured it, so you know 100 ml of deoxygenated blood, how much oxygen it carries? I told you, you cannot say that. You cannot say that deoxygenated blood is not having oxygen. It is having oxygen, but the partial pressure is less there. Okay, but the partial pressure is less there. So 100 ml of oxygenated blood is having 20 ml of oxygen, and 100 ml of deoxygenated blood is having near about 15 ml of oxygen. So tell me, what is the amount of oxygen transported by 100 ml of blood? What is the amount of oxygen transported by 100 ml of blood? Tell me, can I say that 5 milliliter of oxygen is transported by, right, is transported by 100 ml of blood? And you know that in our body, near about 6 liters of blood is present. Near about 6 liters of blood is present. 6 liters of blood is present. Yes or no? So that is the amount of oxygen which will be transported by your 100 ml of blood. This information is important. And when you are doing strenuous exercise, heavy exercise, then instead of 5 ml, it can be 15 ml. Like it depends upon your need. It depends upon the demand of the body. It can be 10 ml, 15 ml. Fine? Fine. And if you talk about the transport of carbon dioxide, 100 ml of blood can transport 4 ml of CO2. Right? It can transport 4 ml of CO2. So that's what you need to remember here, that under normal physiological conditions, 100 ml of blood will carry 15 gram of hemoglobin. 1 gram of hemoglobin binds to this much of oxygen. 15 gram of hemoglobin, right? 15 gram of hemoglobin is having 20 ml of oxygen, and 100 ml of blood contain this amount of oxygen. Clear? Clear. So now let me explain this part. Oxygen hemoglobin dissociation curve, which is S shape. This side is showing partial pressure. This side is showing percentage of saturation of hemoglobin with oxygen. Saturation of hemoglobin with oxygen means what amount of hemoglobin is associated with the oxygen. For an example, let's say you have 200 molecules of hemoglobin, right? I'm explaining it in a layman language so that you can understand it in a better way. Okay, I'm explaining it in a layman language. Why? So that you can understand it in a better way. Clear? Clear? Let's say you have 200 molecules of hemoglobin, and out of that I'm saying that 100 molecules are fully saturated, right? Out of it I'm saying that 100 molecules of hemoglobin are fully associated with saturated with oxygen. Like 100 molecules of hemoglobin, they are totally attached to oxygen. So what will be the percentage? The percentage will be 50%. That 50% of hemoglobin is saturated with oxygen. Simple mathematics. Let me explain again. I am saying we have 200 molecules of hemoglobin. Out of that, 100 molecules of hemoglobin are attached to the oxygen. It means my 50% of the hemoglobin has done its homework. My 50% of the hemoglobin is ready with the oxygen bags. Clear? Understood? Yes or no? Understood? So this y-axis is representing that part, right? This y-axis is representing, it is actually representing that part. Okay, that percentage saturation of hemoglobin with oxygen. Fine. Percentage saturation of hemoglobin with oxygen. Fine. Sure. Everyone, tell me, is it clear or not? If not, I'll explain it again. Sure? Okay. So, second part. This is one part. Array. Clear? बच्चे ठीक है. Again, so see, let's say you have 20 molecules of hemoglobin. 20 molecules of hemoglobin. Okay. Each molecule can bind with 4 oxygens. First of all, tell me, Prangya, is it clear? 20 molecules of hemoglobin we have, and you know that each molecule can combine with 4 oxygen molecule. So I am saying out of these 10, out of these 20, 10 molecules of hemoglobin, they are, right, they are attached, they have their 40 oxygen molecules. For 10 molecules of hemoglobin, they are saturated with oxygen, right? So if each molecule is combining with 4 oxygen, so 10 will combine with 40 oxygen. Simple as that. So 50% of the work is done, Praganya. 50% of the hemoglobin, they are settled, right? 50% of the hemoglobin, they are settled. Just take this hemoglobin and oxygen saturation as their marriage, right? That 10 molecules are fully saturated with oxygen means 10 molecules are married. 50% of your hemoglobin is married. Take it in that way. So that is what percentage saturation we are discussing. Okay, that is what we are discussing basically, right? So here, when you look at this, right, this is actually the proven data, right? So at a partial pressure of 25 mmHg, at a partial pressure of 25 mmHg, of course it is the partial pressure of oxygen, bache. So at partial pressure of 25 mmHg, 50% of the hemoglobin, right, 50% of the hemoglobin is saturated with oxygen. That's the data that you need to remember. That at a partial pressure of 25 mmHg of oxygen, right, 50% of the hemoglobin is saturated with oxygen. That is the data that you need to remember. So this curve and the shifting of this curve, right, this curve and its shifting, okay. So this S-shaped curve and its shifting, it explains the association and the dissociation of the oxygen and hemoglobin. Here in this chapter, you will also read the word affinity. Affinity of hemoglobin with oxygen means that bond. Affinity in general means love, that bond, right? That what is the affinity of hemoglobin to oxygen, right? Jैसे affinity of carbon monoxide is more for hemoglobin if you compare it with the affinity of oxygen with hemoglobin. So what is the meaning of that? It means that if CO, that is carbon monoxide, and oxygen is present, our hemoglobin will bind more with the carbon monoxide. It will form carboxyhemoglobin. I am repeating this again. Your carbon monoxide, which is a poisonous gas, those who smoke, they also inhale the carbon monoxide. So that carbon monoxide, it binds with hemoglobin, right? Its affinity for hemoglobin is more. Like let's say here, I told you na, hemoglobin is like sometimes with this gas, sometimes with this gas. Hemoglobin is like that only. Okay, so hemoglobin is in center. Here you have carbon monoxide, here you have oxygen. Hemoglobin is going to opt carbon monoxide. Right? Why? Because it is having more affinity for carbon monoxide. This is the word that you guys are going to use again and again here in this particular chapter. So all I'm saying is that when this curve, it moves towards this side, you will call it as left shift. Right? Here in this chapter, this is another important topic that we all discuss, right? This is the another important topic that we all discuss. So when your curve will move towards this side, you will call it as left shift of this curve, and when this curve will move towards this side, you will call it as right shift of this curve, right? So now what is this left shift and what is this right shift? Actually, this left shift and right shift, they are going to explain the binding of oxygen with hemoglobin and dissociation of oxygen with hemoglobin, right? Right? Binding of hemoglobin and oxygen, dissociation of hemoglobin and oxygen. So now what we need to study next, the right shift and the left shift. What is it? Fine, this is what we need to discuss. Again, we have a trick, right? Guys, again, we have a trick. You want to know about that? Yes, tell me in the chat section. Do you want to know about that? Yes, sure. So the trick is lard. See, one trick is lord, this trick is lard. Okay, one trick is lord, this trick is lard. What is it? It is lard. Now, what is the meaning of this trick? L for see, L for left, A for association, R for right, D for dissociation. This is the best way to understand it. What is the trick that we have here? The trick here is lard. What is the trick that we have here? The trick here is lard. It means left side is having association, right side is having dissociation. So you know we are discussing it in context of hemoglobin and oxygen affinity. So if I'm saying left side is having association, means if curve is moving towards the left side, there is the oxygenation, right? So there is the formation of oxyhemoglobin, yes or no? There is the oxygenation and there is the formation of oxyhemoglobin, yes or no? Yes or no? And if it is moving towards the right side, it means there is the dissociation of oxyhemoglobin. So if there is the dissociation of oxyhemoglobin, means hemoglobin, oxygen will get separated from hemoglobin. It means oxygen will get separated from hemoglobin. Yes or no? So it means the breakup, isn't it? It means the breakup of your hemoglobin and oxygen. It means the breakup of your hemoglobin and oxygen. Tell me, is it understood or not? Just look at it. Lard, left side association, right side association. Oxygenation association means joining. Joining of hemoglobin and oxygen means association. Right side dissociation means breakup. There will be the breakups. Tell me any doubt here, then I'll explain the next part. Then I will explain the next part. Hanji, next part. Okay. Okay. So now you know that for this addition, right, for the formation of oxyhemoglobin, what are the conditions? You know that the conditions are high partial pressure of oxygen, low partial pressure of carbon dioxide, low H positive ion, means high pH will be there. Okay, and then there will be the low temperature, and even there will be low 2,3 DPG, diphosphoglycerate, which will form during glycolysis. Even if you want to ignore it, you can. Tell me, that's it, yes or no? Tell me, that's it, yes or no? if I'm talking about the association, means the joining, means the patch up of oxygen and hemoglobin. These are the points. These are the points there. So if my curve is moving towards the right side, there is the breakup. So obviously opposite factors will be there, isn't it, bache? That is low partial pressure of oxygen. So it means there will be the high partial pressure of carbon dioxide. So there will be high H positive concentration, right? So high H positive concentration means low pH will be there. Fine, low pH will be there, and there will be high 2,3 DPG, isn't it? These are the factors. And yes, how can I miss temperature? The temperature is also high. These are the conditions for the breakup, right? These are the conditions for the breakup. Yes or no? These are the conditions for the breakup. Yes or no? Yes, Vishal, Deena. See, look at this comparison. There is nothing to cram. If you remember the factors which are favoring association, opposite to it is going to favor the dissociation. And remember, hemoglobin is always after the one which is having high partial pressure, right? High partial pressure. Yes or no? So when will breakup, when will the breakup occur? When? These are the conditions. When hemoglobin is attracted towards CO2. When hemoglobin is like, now I don't need oxygen, I need CO2. Right? My new girlfriend is going to be CO2. And when bache CO2 and hemoglobin join, that's carbaminohemoglobin. The most common mistake that you make. Right? Carbon monoxide plus hemoglobin, it's carbaminohemoglobin. Sorry, carbon monoxide plus hemoglobin, it's carboxyhemoglobin. Carbon dioxide plus hemoglobin is carbaminohemoglobin. It is carbaminohemoglobin. So these are the conditions for the breakup. Okay, matlab dissociation means right shift of the curve. Right shift of the curve. So B4, if B4 is saying breakup, right? If this B4 is saying breakup, right? So can I say that B for breakup, B for Bohr's effect? Tell me. Can I say that B for breakup, B for Bohr's effect? Tell me. Tell me. This topic is literally simple. B for breakup, B for Bohr's effect. So if I'm saying that there is a right shift in the curve, okay, if I'm saying there is a right shift in the curve, so it means dissociation, means breakup, means it is because of Bohr's effect. It is because of Bohr's effect. Understood? Understood? Sure? Sure? So now you know the factors for the Bohr's effect. Now I'll ask one more question. See, now there is a breakup of hemoglobin and oxygen. Now oxygen is going to be sad, yes or no? Oxygen is going to be sad. Oxygen will go to someone else. Oxygen need a support. Oxygen will go to someone else. Oxygen need a shoulder to cry. है ना? So now oxygen, because hemoglobin has left oxygen, oxygen will say bye to hemoglobin. Oxygen will go to our cells, will go to our tissues. Yes or no? Yes or no? This will oxygen do. So can I say that this breakup is important for our cells to survive? This is very important for our cells to survive. If there will be no breakup, oxygen will not leave hemoglobin, oxygen will not go to our cells will not get oxygen, they will not oxidize food, they will not survive. So this breakup is important, it is destiny. Okay? This breakup is very important, it is destiny. So can I say that it is the Bohr's effect which is helping in the transport of oxygen? Bohr's effect is important for the transport of oxygen. Can I say so? Yes, it is the Bohr's effect which is important for the transport of oxygen. Can I say so? This breakup is actually very important for our cells. Hai na? So this is what you need to remember, and that's how your oxygen will be transported. Okay, so you can look at these curves, bache, you can look at these values, right? So left shift, right? High pH, low DPG, low temperature, right shift. These are the factors. So this is actually the Bohr's effect. Fine. This is actually the Bohr's effect. And this left shift, it will take place. Yes, question like this can also come in your paper, right? But see, this left shift, don't you think it will be in the lungs? L for left, L for lungs. Because such conditions where there is high partial pressure of oxygen and low partial pressure of CO2, it will be in lungs. So don't you think in the alveoli it is the left, the oxygen hemoglobin dissociation curve is towards left side? Tell me, ask it from yourself. Don't you think that in the lungs your oxygen hemoglobin dissociation curve is towards the left side? It is towards the left side, right? So in the lungs, this is going on, right, Bache? This is going on in the lungs. So it is actually, this left shift is showing Haldane's effect, right? I will explain it in a different way also. So B for breakup, B for Bohr's effect, patch up is going on in alveoli. It is actually the Haldane's effect. Let me explain this to you. Just allow me some few minutes, okay? Clear? So this part clear. So now let's move. Let's go to our NCERT. Our NCERT is calling us. Okay. So here we have. So see this part. Oxygen dissociation curve is highly useful in studying the effect of factors like CO2 H positive on this binding in the alveoli, where high partial pressure of oxygen, low partial pressure of CO2, less H positive and low temperature is there, they will favor the oxygenation. And in the tissue, opposite conditions are there, they will favor the breakup. And this part, see, in the NCERT it is written like this, but we have discussed it in detail. Remember that every 100 ml of oxygenated blood can deliver around 5 ml of O2 to the tissue. Okay, clear? Done? So next is the transport of CO2, and trust me, you are going to love this topic. And if you will understand this topic, no, then everything is crystal clear for you, right? And I think it is our last major topic, hai na? After it, regulation of respiration and then disorders, which are very easy. You can read it by your own. Okay? So let's discuss this topic and let's finish it quickly. So we need, I think, another 30 minutes. What say, guys? We need another 30 minutes and the chapter will be over. Let's finish it. What say? Arey, tell me na. If you're not interested, then I will end it. I will not continue. Okay, come back then. So next is the transport of this gas, that is your carbon dioxide, CO2, right? That is your CO2. So it can be transported in 3 ways, right? So CO2, like you can say that it is carried by hemoglobin. So when it binds to hemoglobin, it is forming carbaminohemoglobin. I'm repeating it again and again. CO2 plus hemoglobin, it will form carbaminohemoglobin. It's a very common mistake. Many students used to do it. Okay. And when it is CO plus HB, CO means your carbon monoxide, then it will form carboxyhemoglobin. Then it forms what? And then it forms carboxyhemoglobin. Is that clear? Is that clear? So CO2 is carried by hemoglobin, and about 20 to 25% will be carried in this way. We'll come to this. Okay. And obviously this binding is also related to the partial pressure, isn't it? So when partial pressure of carbon dioxide is high, oxygen is low, this is going to happen in the tissue. Fine. This is going to happen in the tissue, right? So there are 3 ways by which it will be transported. See, 70% of the carbon dioxide will be transported in the form of bicarbonates. Clear? 70% of CO2 is transported in the form of bicarbonate, that is HCO3 negative. 20 to 25% will be transported in this way. Yes, bache. 20 to 25% of the CO2 will be transported in this way. Yes or no? Yes or no? And then 5 to 7% Okay, 5 to 7% in dissolved form, like it is dissolved in plasma and it will be transported. So first of all, tell me any doubt here, right? So majority of CO2 will be transported in the form of bicarbonate ions, that is your HCO3 negative. It's a very important question, right? Majority of it will be transported in the form of bicarbonate ions. Clear bache? Sure? Is it clear? Is it clear? If there is any doubt, do let me know. Okay. So now we need to talk about one enzyme and that will clear all your doubts. Right? It's a very bad diagram, but ठीक है, manage. ठीक है, manage. It is our RBC. Fine. It is our RBC, red blood cell. And surrounding में there will be plasma. Isn't it? There will be plasma. Chalo. So first of all, let me tell you about the properties of the red blood cells. Few properties of the red blood cells. Students, red blood cells, na, your RBCs, they are, you know, their membrane is more permeable. Their membrane is more permeable. It is some effect, I don't know, remember the name of that effect. So it is more permeable to bicarbonate, HCO3 negative, and chloride ion. Do you know that? It is a property of the RBC membrane that it is more permeable to bicarbonate ion and to the chloride ion. Okay? To the chloride ion. Clear? So actually what is happening in the plasma? In the plasma you have the RBC. Right? In the plasma you have the RBC. Fine? You have the red blood cells in the plasma. So now here we need to talk about one enzyme, and that is the fastest enzyme. I hope you know that. That is your carbonic anhydrase. What is the name of the enzyme? The name of the enzyme is carbonic anhydrase, and it is the fastest enzyme. Okay, fastest enzyme. Slowest is your ATPase, fastest is your carbonic anhydrase. Clear bache? Clear bache? Fastest is your carbonic anhydrase. And bache, this enzyme is present in your RBC, and right, we will use the short form for this enzyme, that is CA. Okay, this enzyme is present in your RBC. Even it is present in plasma. I'm not saying it is not in plasma, but here its amount is negligible. Okay, its amount is very, very, very less here, but in RBC its concentration is too high, right? So this is the enzyme which is present in RBC. This point clear? This point clear? Sure? Sure, sure, sure. Now CO2 is, you know that CO2 is moving in the, CO2 is transported in the dissolved form as well, right? It is transported in the dissolved form as well, and some amount of CO2 will also join, right? Some amount of CO2 will also join. It will form carbaminohemoglobin and some in the form of bicarbonate. So now this is the part that we need to understand, the bicarbonate form. Right? So we are talking about the carbonic anhydrase. So actually what is happening here in RBC, this is also the scenario. You know now this is carbaminohemoglobin. Now CO2 is there. It will diffuse in here in a RBC, but it will join with water. And do you know with the help of this carbonic anhydrase, do you know that? With the help of this carbonic anhydrase, it is going to join here. Yes, with the help of carbonic anhydrase, it is going to join here. Yes or no? All this reaction is reversible, but here, because we are talking about the RBC only, so let's draw it like this. In the presence of carbonic anhydrase, it will form H2CO3. What is this H2CO3? It is carbonic acid. It is carbonic acid. These reactions are important, students. These reactions are important. Your CO2 is joining with water in the presence of carbonic anhydrase. It is forming the bicarbonate. It is forming the carbonic acid, right? It is forming the carbonic acid, and this is a weak acid. Immediately it will dissociate into this. It will dissociate into this bicarbonate and H positive. Are you getting it? It will dissociate into bicarbonate ion and H positive. Now I hope you will understand one thing. I told you when partial pressure of CO2 is high, the pH will decrease, H positive will be more. Now I hope this is making sense here, right? I hope it is making sense here. Because CO2 high means it will form carbonic acid, it will dissociate, and it will form this H positive. Is it making sense to you now? Is it making sense to you now? Sure. And do you know where will this hemoglobin go? This hemoglobin is going, this H positive will bind with hemoglobin. Do you know that? What will happen to this H positive? What is going to happen to this H positive, which is, decreasing the pH, which is making it acidic, Actually, this H positive is going to bind with hemoglobin and it will form hemoglobinic acid. It will form hemoglobinic acid. Remember this. What is going to happen? It is going to form hemoglobinic acid. Now, see, you know that blood is having a pH of near about 7.4. We used to say blood is having the property like it is a buffer. It shows the buffer action. That's what we discussed, that your blood shows the buffer action. So actually this hemoglobin here, this hemoglobinic acid here is acting like a buffer. You see now, excess of H positive, it is going to join with hemoglobin. It will form hemoglobinic acid so that pH will be maintained. And moreover, the formation of this hemoglobinic acid is also, right? See, when these conditions are possible, when partial pressure of carbon dioxide is high, so obviously it is favoring the dissociation, the breakup of oxygen and hemoglobin. It is favoring the Bohr's effect, which will help in the transport of oxygen. Understood? Which will help in the transport of oxygen. Understood? Yes, bache? Yes, bache? Now you know that RBC is having your carbonic anhydrase. Even plasma is also having carbonic anhydrase. No doubt its amount is very less. No doubt its amount is very less, but still your plasma is also having carbonic anhydrase. So it means some bicarbonates are also there here, are present in plasma. Your bicarbonates are also there in plasma. Now these bicarbonates, they are very stubborn, right? Like a stubborn kid. Like some kids used to do, they just lay down outside a shop and they'll be like, I want that toy, at any cost I want that toy, right? Some people used to do things like that. I hope you guys are aware of it, right? Some used to do things like that. Hannah, you are aware of it. Okay, so same is the case here. This bicarbonate will be like, I'll go out. I want to go out in the plasma. I want to diffuse out in the plasma. And obviously, here its concentration within the RBC is more, outside it is less. So of course, it is saying, I want to go out, I want to go out. But the point is that if we will send these bicarbonates here in the surrounding, it will cause some disturbance. The balance will not be maintained. It is going to create disturbance here. So just to balance that, no doubt, your HCO3 negative diffuses from RBC to plasma, right? So just to maintain that balance, that ionic balance, your chloride ions, they'll be sent from plasma to the RBC. They'll be passed from RBC to the plasma to the RBC, right? So bicarbonates are going out, chloride will come in. Bicarbonate is going out, chloride is coming in. And what is it doing? Why are we doing it? Just to maintain that balance, that ionic balance, right? So ultimately it is resulting in that electrochemical neutrality, right? It will keep it neutral. It is having -1 charge, it is having -1 charge. So neutrality is maintained. Electrochemical neutrality is maintained. So what is happening? HCO3 negative diffuses out from RBC to plasma, right? And chloride ion diffuses in from plasma to RBC. So this is very important because they ask the movement of ions. In the final paper, they can ask you the movement of ions, right? So this is something very important. This is something very important. Are you getting it? Yes? Clear? So HCO3 diffuses out from RBC to plasma, chloride diffuses in from plasma to RBC, right? Diffuses in from plasma to RBC. So this phenomena, this shift is actually the chloride shift. See, it's very easy. It is not given in NCERT, but yes, it is important. Chloride shift, it maintain electrochemical neutrality. We also call this shift as Hamburger phenomena. Okay, this is also known as Hamburger phenomena. Okay, this is the chloride shift. So I told you now, this RBC membrane is having the property, it is very its permeability for bicarbonate and chloride is more. Is that clear? Yes, bache. And do you know here, these bicarbonates, they join with sodium ions. Do you know that in plasma, these bicarbonates, they join with sodium ions? I'm not going to write down the points. You have to note it down. Fine. So here, these bicarbonate ions, they will join with the sodium and they will form sodium bicarbonate. Right? They are going to form sodium bicarbonate. That is your NaHCO3. Right? So this is going to happen, and that's how your carbon dioxide will be, right, transported. Is that clear? Is that clear? Hamburger phenomena and everything clear. So 70% of the carbon dioxide is transported in this way, right, as bicarbonate ions. Clear, bache? Clear, clear, clear. So can I say that it is the deoxygenated blood? Yes. Can I say that it is the deoxygenated blood? You tell me, please. Can I say that it is the deoxygenated blood? So now where will this deoxygenated blood go? It will go to the alveoli for the oxygenation. Now where will it go? It will go to the alveoli for the oxygenation. Yes or no? So now in the alveoli, bache, you will see Haldane effect. Okay, you are going to see the reverse reaction. What will you see here in alveoli? You are going to see the reverse reaction in alveoli. Right? You know about this reaction. Opposite to it will take place here in the alveoli. Right? So deoxygenated blood will pass to the alveoli. So now what is going to happen? So what are the conditions in the alveoli? We know that partial pressure of oxygen is high. We know that partial pressure of CO2 is less. So if partial pressure of oxygen is high, right, and the partial pressure of CO2 is less in alveoli, don't you think that this oxygen will join with hemoglobin here? It will form the oxyhemoglobin here. In the alveoli, don't you think that will be the condition? Yes or no? Yes or no? Tell me, bache, we are about to finish this chapter. In the alveoli, I am saying that reverse reaction will occur. There will be the Haldane's effect. Partial pressure of oxygen is high there. Partial pressure of CO2 is less there. So because of that, oxyhemoglobin will form. Yes or no? And this oxyhemoglobin, it tends to displace CO2 from blood, right? And that is what we need to do in the alveoli, so that this CO2 can pass out, isn't it? So that the CO2 can pass out. Clear, bache? And why is it happening here? Why? Because this oxyhemoglobin, note down this point, it's a stronger acid. Okay, it's a stronger acid than hemoglobinic acid. It's a stronger acid than hemoglobinic acid. I told you that in the deoxygenated blood, hydrogen ion is attached to the hemoglobin, which will form hemoglobinic acid. Okay, fair enough. It needs to maintain the pH. But now when the deoxygenated blood will pass to the alveoli, now what is going to happen here? In the alveoli, we need to release the CO2. We want to release the CO2. Right? We don't want that CO2 to occur there, to stay there. We want to exhale that CO2, and that's important. So here, right, partial pressure of oxygen is high. Now it is going to favor that association. The patch up of oxygen and hemoglobin will occur. So what is going to happen here? Oxyhemoglobin will form. Why? You know that it is always about the stability. It is a stronger acid than hemoglobinic acid. So obviously here there will be the formation of oxyhemoglobin rather than hemoglobinic acid. First point clear. There will be the formation of oxyhemoglobin, then the hemoglobin itself, or then the hemoglobinic acid itself. Yes, right. It is actually the hemoglobin, not the hemoglobinic acid. It is the hemoglobin actually. Okay. So it is the hemoglobin which is, so oxyhemoglobin is stronger than hemoglobin. So here, because oxyhemoglobin is more stronger than hemoglobin, definitely hemoglobin will immediately pick up oxygen, right? And it will try to displace the CO2 from blood. It will throw out that CO2 from blood, yes or no? Yes or no? Right, right. And that CO2 will be picked up by that Haldane's effect, right? This CO2, what is going to happen, right? This CO2 will be picked up by that Haldane's effect. Now, what is the meaning of it? What is the meaning of it? Now, bache, oxygenation of blood will cause release of H positive from your hemoglobin, isn't it? I'm telling you now that oxyhemoglobin is more stronger acid than hemoglobin or hemoglobinic acid. So basically, see, let's say this is the scenario. Let's say in the lungs, this is the scenario. You know that in the deoxygenated blood, you have hemoglobinic acid, isn't it? In the deoxygenated blood, you have hemoglobinic acid. That is H, this one. Now, because here partial pressure of oxygen is more, this hydrogen ion will be displayed. It will be released. It will be separated from hemoglobin. Hemoglobin is like, oh my God, oxyhemoglobin is more stable. Let's leave this part and let's become oxyhemoglobin. This part clear? This part clear? Sure. Now, this H positive will be picked up by the bicarbonate ions. You know that in the deoxygenated blood, bicarbonate ions are there. Even, you know that NaSCO3, its breakup will occur here, no? Sorry, NaSCO3, the sodium bicarbonate, again it will dissociate here, na? So basically, bicarbonate ions are present there. Bicarbonate ions are present there. Yes or no? So this H positive also combines with this HCO3 negative and it will again form H2CO3 bache, carbonic acid, and this carbonic acid will again dissociate and again you will get the CO2 and water. Right? I told you, no, reverse reactions are going to take place. So hydrogen ions combine with the bicarbonate, which is released due to the breakdown of sodium bicarbonate, right? And carbonic acid is formed, which will again split into carbon dioxide and water. Clear, bache? It will again split into carbon dioxide and water. So this carbon dioxide will be released out of the body. So that is how. So in the alveoli, what is going on? In the alveoli, Haldane's effect is going on, and this Haldane effect is responsible for that transport of CO2. It is the one which will throw that CO2 out of our body. So reverse set of reaction. You know about these reactions, right? So the reverse reaction will take place in alveoli. So in alveoli, actually again HCO3 negative and H positive join. Again carbonic acid will form. Again that will dissociate into carbon dioxide and water. Carbon dioxide will be moved outside. Clear? So that is all about the Haldane effect. That is all about the Bohr's effect. This is all about this chapter. Okay? This is all about this chapter. Clear, bache? Yes? It is all about this chapter. So now we have to discuss the regulation of the breathing rate, and then finally the disorders. Okay, finally the disorders, and the chapter will be over. Okay, so let's discuss it from this part only. So regulation of respiration, right? Then we will finish it. So what do we have? We have regulation of respiration. So it will be done by two ways. Of course, the nervous control, brain is going to, brain will be involved here, and your chemical control, right? So two things are there. One is your, yes, one is your brain, obviously the respiratory center, and another is your chemical control. One is the respiratory center and another one is of course the chemical control. Okay. So firstly, let's talk about this. So when it comes to the respiratory center, it is there in the medulla oblongata. And you remember, na, medulla oblongata is the part of hind brain. It is the part of hind brain. So it is the part having the respiratory center. Okay, it is the one which is having the respiratory center, and it is going to initiate that wave of control. It is going to initiate the inspiration. Okay, it is going to initiate the inspiration. Actually, when you talk about the medulla oblongata, you talk about dorsal respiratory group, like it is a group of neurons, of course. Dorsal respiratory group. I will only teach whatever is in NCERT. I am just giving you an overview of it. and then you also talk about the ventral respiratory group here. Okay, you also talk about the ventral respiratory group here. Okay, in the medulla oblongata you have dorsal respiratory group as well, you have ventral respiratory group as well. Okay, so mainly it is the dorsal respiratory group, which mainly causes inspiration. Okay, it is the majorly responsible for this inspiration. This part clear? It is mainly responsible for the inspiration. So it is the one which will send the signal to the inspiratory muscles, and inspiratory muscles are going to contract for 2 seconds. Inspiration is for 2 seconds. That is an active process. So this dorsal respiratory group, which is located dorsally in medulla, it is responsible for that. Fine, it is responsible for that. Clear, bache? Clear. Okay, and this ventral respiratory group is responsible for both inspiration and expiration. It can control both inspiration and expiration. And especially bache, when respiratory activity of our body increases, then it will become active, and it is for forceful inspiration and expiration. Okay, it is for forceful inspiration and expiration. So in simple way, you can remember that medulla oblongata is having the respiratory center, which is going to cause the inspiration. Now, bache, I have a point. Okay? Here I always give the example of mummy and papa. This is sometimes the mothers are lenient, right? Mothers are lenient, right? So let's say you're asking money from your mother will be like, you asked for 150 rupees, and your mother is like, yaar, you please take 200 rupees. It happens now. Maybe in your home the story is different, but right now we have to take this example. Same is the case here in brain. We have pons varoli also. P for papa, M for mama. So mama is lenient. Mama is like, okay, baby is asking for the money. They are asking for, let's say, kids are asking for 150 rupees. She is giving 200 rupees. But then, right, when mother was about to give 200 rupees, papa is like, oh, right? Papa is trying to control. Papa is trying to restrict that. Papa is like, no, limit it. If they are asking for 150 rupees, just give them 150. No need to give for 200. No need to give them 200 rupees. Fair enough. Obviously, it is important. Right? Same is the case here. No doubt it is the medulla which will initiate, which will cause inspiration. But your pons varoli, right? It is going to restrict that. It is going to limit that. Fine. It is going to restrict that. It is going to limit that. Clear. It moderates the function of respiratory rhythm center. It moderates the function of respiratory rhythm center. Respiratory rhythm center is present in medulla, so its function will be moderated by pons varoli. It is having apneustic center and pneumotaxic center. Clear? It is having apneustic center and it is having the pneumotaxic center. Fine? Yes, bache? Done, bache? So apneustic center will check the depth of the inspiration, and your pneumotaxic center will send the signal to the dorsal group, right? Dorsal respiratory group of the medulla. Chalo, so now let's revise it from NCERT. Human beings, they have a significant ability to maintain and moderate the respiratory rhythm. Homeostasis, of course, right? So this is done by neural system, I told you. So we have a specialized center in medulla of the brain. This question can be asked that where is that respiratory rhythm center present? It is in medulla. Okay, so it is responsible for the regulation. Another is pons region, where you have pneumotaxic center, but it sends signal to the dorsal respiratory group of medulla. It moderates the function of respiratory rhythm center. Okay, so neural signal from this center, it can reduce the duration of inspiration and alter the respiratory rate. So in the NCERT, they are not talking about apneustic center, but actually in the pons varoli, this center is also there, bache. So along with this pneumotaxic center, it is going to limit the depth of the inspiration. Fine, it is going to limit the depth of the inspiration. Fine, bache. So next is your chemical control. So chemosensitive area is situated next to the rhythm center. It is highly sensitive to carbon dioxide and hydrogen ion. So once there was a question in the paper, bache, from this part, they were asking that chemosensitive area is highly sensitive to CO2, to H positive, both Yeah, none of these. So you should know it. It is sensitive to carbon dioxide as well as hydrogen ion, right? So whenever these substances, they increase, it will send a signal to this chemosensitive area. Clear, bache? Clear, bache? And that will tell it to the respiratory rhythm center that now it is the time, please get active and please control it, make the necessary adjustments. Clear? Make the necessary adjustment. And as I said initially, the amount of CO2 in arterial blood is the trigger for the inspiration. Okay, so if partial pressure of CO2 in arterial blood is increasing, it is actually the trigger for the inspiration. Fine, it is actually the trigger for the inspiration. So you can see, bache, the receptors associated with aortic arch and carotid artery. Carotid artery is the one which supplies the oxygenated blood to brain. Aortic arch, from left ventricle it is arising, right? It is going to innervate. We are going to give oxygenated blood to the entire body except lungs. So it is going to recognize changes in CO2 and H positive concentration, send signal to the rhythm center, and then they will start their roll, right? So inspiration is controlled by CO2, not by the oxygen. Not by the oxygen. So that is something very important. And then comes the disorders where your asthma, emphysema, both are important. Emphysema is, bache, caused by the cigarette smoke, mainly by the cigarette smoke, right? Emphysema. So alveolar walls are damaged, respiratory surface is decreased. So cigarette smoking is the main reason. So you will tell me what is alpha-1 antitrypsin in the comment section. This is your homework. And let me tell you, it is related to emphysema. You will study it in class 12. So that's your homework. So in the comment section, this is what you are going to answer. And asthma, difficulty in breathing causing wheezing. Wheezing is a sound. You know, when your nasal pathway, when your airway is blocked, now some sound is produced. That is wheezing. So it is due to the inflammation of bronchi and the bronchioles. Clear? It is due to the inflammation of bronchi and the bronchiole. So occupational respiratory disorder, like some people, they work in the, mines, coal industry, and because of that, the dust particles, they will enter. So body's defense system will get activated. Your alveoli are covered with the fibrous tissue. So proliferation occurs. So asbestosis, silicosis, these are the occupational respiratory disorders. So question used to come from the disorder and especially from this chapter. So I will make a separate video on it, right, where we will only discuss about the disorder. So this is your homework. You are going to note it down and you are going to make the notes on it, right? So finally we are done. Okay, we are done with this particular chapter as well. So in the next class we'll be starting, right? We'll be starting, oh yes, do hit the like button. So we are going to start the body fluid and circulation. Okay, so we'll start the plant physiology soon, and in the morning we are doing the genetics, and tomorrow also at 10 AM you have a lecture on genetics as well. So guys, please start revising properly, start studying properly, do not waste your time. Okay, just take it in this way that this is for the last time you're trying for NEET and you have to give your best. Okay, so you know that we are here to support you. You know that this is the batch link, right? We are just one click away from all of you. Just click on this link. This is what you will get. Add your number and email, and in this price, at a price of just 4,999, you will get this batch. Okay, so we'll share the PDF in the Telegram group. Hopefully today I will share. I need to share many PDFs, so today I will share. So till then, you know what you have to do. Yes, you know what you have to do. It will hardly take you a few seconds. Do let me know in the comment section that you liked the session or not, right? What are your views regarding this session? Let me know in the chat section. So thank you so much for watching.